Good morning, buenos días, colleagues and friends of the University of Illinois, Chicago, University of Illinois, Urbana-Champaign, and the University of Illinois, Springfield. Buenos días, estimados colegas y amigos de la Universidad de Illinois. On behalf of the University of Illinois system and the Illinois Mexican and Mexican American Student Initiative, IMAS, I welcome you to this international webinar on food and nutrition, focus on childhood obesity in Mexican and Mexican American families. Bienvenidos investigadores de varias instituciones de México. A special welcome to students, distinguished authorities, researchers, and executives from different institutions. Gracias por su distinguida presencia. We appreciate your presence. My name is Elvira de Mejía. I'm a professor at the University of Illinois, Urbana-Champaign, and the director of the University of Illinois System initiative called IMAS. I'm humble and thankful to facilitate this critical and urgent initiative. I thank the University of Illinois System President, Dr. Timothy L. Kalin, for his leadership and enthusiasm for recognizing the need and opportunity IMAS presents. IMAS represents a culture of support, building pipelines for Mexican and Mexican American students, smoothing the path, retaining as many talented students as possible, and building a network of collaborators. IMAS is about partnering with our peers in Mexico. IMAS will enhance ongoing efforts by the system's 3 universities to increase Mexican and Mexican American recruitment and expand their educational opportunities. IMAS organized this symposium on childhood obesity in Mexican and Mexican American families in collaboration with the Instituto Nacional de Ciencias, Médicas y Nutrición, Salvador, Zubirán, and the University of Illinois, Chicago. This webinar will highlight cutting-edge research, including multidisciplinary aspects of obesity, and discuss prevention and treatment strategies from a comprehensive perspective. We have the extraordinary participation of 12 experts on different aspects in the field of obesity, including the president of the World Obesity Federation. Among the participating institutions are the Instituto Nacional de Ciencias Médicas y Nutrición, Salvador, Zubirán, the College of Applied Health Sciences, University of Illinois, Chicago, the Instituto Nacional de Salud Pública en México, the Instituto Nacional de Medicina Genómica, Departamento de Química UNAM, the Personalized Nutrition Initiative at UIUC, the University of Illinois Extension, el Hospital General de México, the Department of Kinesiology and Nutrition, University of Illinois, Chicago, the College of Medicine, Department of Biochemistry, Universidad Autónoma de Nuevo León, México, the College of Natural Sciences, Universidad Autónoma de Querétaro, México. I appreciate your willingness to share your knowledge and work together for the well-being of children. Up to this morning, we were close to 1,700 registered participants. This is such an important topic. A few days ago, the Global Obesity Coalition, consisting of the United Nations Children Fund, World Health Organization, and the World Obesity Federation, hosted the Obesity and Youth, Young People Catalyzing Change webinar to unlock conversions around how obesity affects the lives of young people around the world and the concrete change young people are both leading and demanding. We thank all authorities and representatives of different institutions for their presence and remarks, especially Dr. Pradeep Khanna, Associate Vice President for Corporate and International Relations of the University of Illinois System, Doctora Marta Kaufer-Horwitz, Director of Nutrition, and the General Director, Dr. José Cifuentes Osornio, both from the Instituto Nacional de Ciencias Médicas y Nutrición, Salvador, Zubirán, México, that will give welcome remarks in a few minutes. I want to give a special recognition to Doctora Claudia Tovar Palacio, a researcher at the Instituto Nacional de Ciencias Médicas y Nutrición, Salvador Zubirán, an alumna of the University of Illinois Urbana-Champaign, for all her efforts and collaborations in the organization of this symposium and for her tireless work contributing to solving the children obesity problem. Each speaker will introduce themselves before their presentation, and moderators will be present during Q&A section. Write your questions in the Q&A, and we will request the speakers to answer your questions. The webinar will be recorded, and the video will be posted on the IMAS website soon. Thanks to personnel from the UI System President's Office, Nancy Salinas, Chelsea Moore, Regina Harrington, and Eric Olson for their behind-the-scenes work, and Mr. Aldo Mora from UNAM Chicago for live stream on Facebook. Also the moderators, Dr. Crespo, Tovar, and Kaufer. We will start with Dr. Pradeep Khanna, Associate Vice President for Corporate International Relations at the University of Illinois. Please, Dr. Khanna.
And thank you, Elvira. Good morning to all of you. It's an honor for me to join the company of so many distinguished scholars from leading institutions in Mexico and in Illinois. I want to express my special thanks to Dr. Martha Kaufman-Horowitz and Dr. Jose Cifuentes Osornio for taking time off their busy schedule to join us and to partner with us on putting together this symposium on a very important topic, the topic of food and nutrition focused on childhood obesity in Mexican American families. Childhood obesity does not recognize national frontiers. It does not recognize any boundaries. Though today we are focused on Mexican and Mexican American populations, the learnings from this symposium will be applicable to people all across the world. As we all know, the problem of childhood obesity is becoming a major health crisis in many countries, both developing and developed. Professor De Mejia talked briefly about the IMAS initiative and how it was established. It has been wonderful what Elvira has done with the initiative in the last 3 years. When President Killeen was looking for someone to lead the initiative, we all turned to Elvira. She went through the most scientific, methodical process of extensive consultation with faculty, researchers, students at our university, at the University of Leicester, but then also talked to colleagues at a large number of universities in Mexico and worked with them to come up with a vision for IMAS, which was not only to serve the needs of Mexican and Mexican American students at our universities, to make sure that they have the best possible experience while they are on the campus, but also created one of the most robust research programs involving scholars from our universities and from our partners in Mexico. When we talk of University of Illinois, we often talk about engineering, we talk about health, we talk about environment, we talk about food and agriculture. However, our partnership with universities in Mexico, with our colleagues there, goes well beyond any academic discipline. It touches all aspects of human well-being and citizens in our global society. So I think it's extremely important to recognize the importance of sharing knowledge, the importance of bringing together scholars from Mexico and from the US to work together to understand the problem of childhood obesity, to find solutions for that, to find treatment strategies, and then see what are the best ways of implementing them. As we are here together, I see we are already over 400 people on the webinar. Let's recognize the gravity of this challenge and the need for collective action to find effective solutions. As I said earlier, childhood obesity is a complex issue with multifaceted causes and consequences. It touches upon various aspects of our lives, from dietary habits and physical activity to socioeconomic factors and cultural influences. Today, our goal is to foster a comprehensive understanding of these factors, exchange knowledge, and collaboratively explore strategies for prevention and treatment. As I said, and as you will all agree with me, we have to acknowledge that childhood obesity is not confined to national borders. It is a shared challenge that requires collaboration beyond geographical boundaries and constraints. Today, we are not just discussing a health issue, but also reinforcing the bonds between our communities, recognizing the interconnectedness of our two nations. Global partnerships like this one with Mexico are the recipe for success in the world, where progress and economic growth are increasingly tied to the power of education, discovery, and innovation. IMAS is a new path that will guide us to a better tomorrow. We are the fuel that will drive it. We constitute the broad-based, bilateral, forward-focused network that will provide more and more Mexican and Mexican-American students with the opportunity to study at our system, the University of Illinois system, that consists of 3 best-in-class universities and the Discovery Partners Institute. And these universities have multiple institutes working on different aspects of childhood obesity. I once again extend my gratitude to the leadership of the institutions that helped organize today's symposium. There's no limit to what we can achieve working together to help people who live together and make their lives and help them live longer and healthier lives. Thank you all for joining us today, and I look forward to listening to the presentations and I'm sure improving my own understanding of the issue of childhood obesity and how we can find solutions to it. Welcome to all of you again. Thank you, Elvira.
Thank you, Dr. Cana, for your remarks. Now we have some remarks from Dra. Marta Kaufer-Horwitz, the Director of Nutrition of the Instituto Nacional de Ciencias Médicas y Nutrición, Salvador, Zubirán, México. Dra. Kaufer, please.
Good morning, everyone. I feel very honored by this collaboration between the University of Illinois System and the Instituto Nacional de Ciencias Médicas y Nutrición, Salvador, Zubirán, a National Institute of Health in Mexico. My name is Marta Kaufer-Horwitz, and I'm the Institute's Director of Nutrition. I am a dietitian and a doctor in science with concentration in epidemiology. And before being appointed nutrition director, I was a researcher in medical sciences at the Institute's Obesity Clinic, from where I have addressed the issue of obesity from the clinical and public health perspectives. Since you registered to this symposium, you should be aware that this is a delicate and worrying topic for the world population, and our countries, both the United States and Mexico, are no exception, as has been pointed out earlier. Both our institutions have been collaborating for several months now to offer you this symposium on a relevant topic that affects our countries. The discussion of the problem of childhood obesity in Mexican and Mexican-American families is key to finding a solution to attenuate the problem and ultimately to prevent new cases of obesity in our populations. Our common objective through this symposium is to promote the exchange of knowledge and experiences on this highly relevant topic for both countries, address multidisciplinary aspects of obesity, and discuss prevention and treatment strategies and options from a comprehensive perspective. Our expert researchers from both Mexico and the United States will discuss a variety of topics on childhood obesity, from the molecular all the way to the social perspectives. We thank them all for their willingness to share their knowledge and expertise with us today. Thank you very much. We hope that the topics that will be discussed will be of great interest to you, raise concerns and new questions, and serve as a basis for a rich academic exchange with the researchers at the end of their presentations or result in future partnerships. We hope that this will be the first of many collaborations between our institution and the University of Illinois system, both in academic events such as this one and in research projects where we can identify common areas of interest that solve relevant problems in both our countries. I would like to thank Dr. Elvira de Mejia and Dr. Carlos Juan Crespo for inviting our institute to co-host this symposium. It has been a real pleasure working with you all along. I also want to recognize the hard work of Dr. Claudia Tovar Palacio for being the motor of this partnership. And I would now like to introduce Dr. José Cifuentes Osornio, General Director of the Instituto Nacional de Ciencias Médicas y Nutrición Salvador Zubirán in Mexico, who has given us all his support to make this collaboration possible and who would like to convey a welcome message. Thank you very much for this opportunity. I wish all of you a challenging and productive morning. Thank you very much.
Thank you very much, Dr. Kaufer.
Good day to everyone. I am so pleased by this collaboration between the University of Illinois and the Instituto Nacional de Ciencias Médicas y Nutrición Salvador Zubirán, one of the national institutes of health in Mexico. My name is José Cifuentes Osornio, General Director of this institute. By training, I am a specialist in internal medicine, infectious diseases, and clinical microbiology. Before, I was the medical director for 10 years. The activities of this institution have been oriented to medical service, to biomedical and clinical research, postgraduate education, and the study of some problems related to nutrition in the general population. Both our institutions have been collaborating for several months now to offer you this important symposium on a relevant topic that affects both countries, related to obesity in childhood, in Mexican and Mexican-American families. The objective of this initiative is to promote the exchange of knowledge and experience on this topic of great interest for the population of both countries, to analyze multidisciplinary aspects of obesity and discuss prevention and treatment strategies. Our experts in clinical and biomedical research from Mexico and the United States will discuss several aspects on childhood obesity from the molecular to the social perspectives. We thank all of them how integrate this very important initiative to provide new knowledge and expertise to us this day. I hope that this will be the initiation of a strong collaboration between our institution and the University of Illinois, both in research projects and in academic events, and eventually to identify areas of major interest to solve some of the problems in people from both countries. Thank you very much. I hope this event be an excellent opportunity to see new venues to develop different projects and programs in the future.
Thank you to all of our leaders. And now we are going to get started. So our next speaker is Dr. Carlos Crespo. Dr. Carlos Crespo is the Dean of the College of Applied Health Sciences, Professor of Kinesiology and Nutrition, College of Applied Health Sciences, University of Illinois, Chicago. Dr. Crespo is one of the organizers of this webinar, and we thank him for his leadership. Dr. Crespo, please.
Thank you. Can you hear me okay?
Yes.
All right, good. Good morning. Buenos dias, everybody. It's an honor for me to be invited and take part in this symposium. It's allowed me to build in some of my prior work and to share with you some primarily data, given that I just want to provide the background and some prevalence on obesity, physical activity, and then we'll have some time for questions and answer. So I'll talk about backgrounds, and then we'll do obesity and physical activity. But it's important that we get an idea of what we're talking about. We are going to use the term obesity as the 95th percentile for height and weight. Some of you might be familiar with the growth charts. So a lot of the data I'm going to report to you today is coming from the National Center for Health Statistics, place I used to work. The term obesity refers to children that are at the 95th percentile. Overweight, it's a new term, it refers to the 85th percentile. I think most of the data I have is about obesity. So it is a statistical definition of obesity. For adults, for many years, we had a statistical definition of obesity, and then we finally came up with the definition that is actually related to morbidity and mortality. For children, on the other hand, what we have is a statistical definition. Just keep that in mind. We do know that childhood obesity is been increasing. It's highly prevalent in the United States. It has double or triple in many cases, and that this prevalence is actually higher among minority populations and population of low income. It is not a unique problem for the United States. Obesity is growing in every country around the globe. I don't think there's been a country that has not seen an increase in obesity from one year to the next. And that's alarming. We, the United States, have one of the highest rates of obesity in the world. Now, I want to talk about, we're going to talk about Mexican-American children. If you follow the demographic of the United States, the Hispanic groups, Mexican-Americans are by far the largest Hispanic subgroup. It's about 2/3 of all Hispanics are Mexican-American. And even when you look at the subgroups other than Puerto Ricans, Mexican-Americans continue to be the largest. So when we talk about Hispanic data, and I'll try to, as much as I can when I have data on Mexican-American, to make sure that it's for Mexican-American. but it reflects the health status of Mexican American. Now, this is at the total population. When we look at children, 25% of US children are actually of Hispanic ethnicity. Among adults, it's 18%. Now, if you look at public school, that number is even higher because the percent of people who go to private school primarily white. When we look at public school, this number here of 25% is in some places, we're talking about half or more of the children attending public school, especially elementary school, are Hispanic. Now, this is an interesting slide about the Gen X and boomers, et cetera. Most recent groups, those younger than 18, the percent of Mexican American is actually 69%. So the number is large and it's getting larger, okay? And this provides a background for the significance of the importance of looking at Mexican American children and the relationship to obesity. Now, this is an interesting slide because I saw it and I realized the impact that this could have in a Mexican American child. The United States has the highest rates of obesity. Mexico has the second highest rate of obesity. That is your ecosystem. If you're a child who is growing up in a bicultural home, whether you grew up in the US or you grew up in Mexico, you are being exposed to high rates of obesity around you. If you're a child from the US and Japan, you can have a contrasting figure, but if you're Mexican American, your two exposure are places that have high rates of adult obesity. Now, with that as a background, let me share with you the prevalence of obesity. Some of this work I did when I was at NCHS, but I've had some more updated information. First of all, we're going to use BMI, body mass index. So it's a very quick and dirty measurement. It is very good for epidemiological study, for population-based study. It's not a diagnostic tool. BMI, people criticize that it's not perfect. It is not perfect, but it has a very, very good positive predictive value. Those in epidemiology know what that means. It just predicts very good how much adiposity a child might have. So there are a couple of what I call money slide. This is a money slide. This is overall. So remember when I told you that obesity is defined as the 95th percentile. So if that's the case, 5% of children would have obesity. And this is data from 1963 to 1967, and that was the baseline. And for the most part, you will see that the prevalence of obesity was around 5%. And that 1963, 1971, it is what we expected, that only 5% of the children would have levels, would be classified as having obesity. And this is from 1971, 1972. And that happens for boys and girls, 6 to 11, 12 to 19, boys and girls. Now, if you notice in 1976 and 1988, the prevalence of obesity increased sometimes by triple. So we're talking 100, 200, 300%. And in 1999, by the turn of the century, the prevalence of obesity was already 3 times what it was in 1963. What this means is obesity changed faster than you can change the genetic pool. Because one of the conversations is, oh, it's genetic. It's not genetic. This is the gene pool does not change this fast. So this is a symbol of something that's happened environmental. And I'll hint a little bit about that at the end. But this is serious. Remember when I say that the prevalence of obesity is higher among minorities and low-income populations? So if this is what's happening at the general population, our communities are actually disproportionately impacted by obesity. Now, when we have data among Mexican Americans, this is 1988 and this is 2008, so now we're passing 2000, we see that Mexican American boys have higher rates of obesity than in 1988. So it not only did it get worse from 1963 to 2000, by 2008, the problem got actually worse, and it got worse for Mexican American boys. and it also got worse for minority kids, less so among Mexican-American girls, but yet there's been a trend to increase prevalence of obesity. Now, if we go back to 1999, just looking at, this is the other money slide. This is year 2000. This is the prevalence of obesity. And these are Mexican-American children, 12 to 19. It has been increasing every year to 30.6. We talked about health disparities, and we talk about health inequity. This is a great example how we can define these two terms. Health disparity is a group of people that have higher prevalence of exposure of something, and you can see that there is a disparity between whites and minority children. And this disparity is, we need to eliminate those disparities. We were making progress. We're eliminating the disparities. I mean, these three groups will come together. You don't want it to come together by having increases in one group and not reduction in the other one. But this is an example of, we were making progress eliminating the health disparities. This is health disparity. Now, this is a health inequity. Something happened where we are able to see reductions in obesity for non-Hispanic white children, but we are seeing increases among prevalence of obesity among Blacks and Mexican-American children. This is an inequity. It's morally wrong too, but this is an inequity. It probably means something is happening among one group that allows them to have a lower prevalence of obesity, but among other groups, like I said, this is not genetic. This is one, I would say, completely environmental. Why is it that these groups have higher rates of obesity? Now, this is Mexican-American children only, and this is the 30.6% that I was sharing with you. This is 12 to 19. If you look at 6 to 11 years old, we also see in 2000, we were about 22.3, 22%, and we are 28%. For those 2 to 5 years old, it was about 13% and it's 17%. So the trends for these groups is pretty much on the wrong direction. We're just seeing more increases in obesity among our Mexican-American children. And that reflects on what we see among adults, that higher prevalence of obesity is higher among Mexican-American men and women. These are actually African-American. So here's what I wanted to share with you. What we know is, and this is also an introduction to the next part on physical activity. The more a child watches TV, the higher the prevalence of obesity. And we published this a long time ago. And we had a nice editorial that says, well, this is a correlation. This is the more TV a child watches, the higher the prevalence of obesity. It doesn't mean that watching TV causes obesity. It might be that obese kids like to watch more TV. And that's a fair point. So we did a second analysis of our data. And we noticed that the prevalence of obesity is higher among Mexican-American children than it is for whites. African-American kids also have high rates of obesity. But what we noticed, there was a 24-hour recall. And what we noticed is the difference in calorie intake between boys and girls among those who watch 1 hour of TV and those who watch 5 hours of TV, it's about 150 calories. If you look at calories here and calories here, we're talking about 150 calories. So it means, you're watching TV, you're probably eating more. 150 calories is really not, it's probably half a cookie, maybe a whole cookie. 1 cookie a day doesn't do harm, right? If you multiply 150 calories times 365 days, divided by 3,500 calories, which is what equivalent of 1 pound of fat, we're talking about 15 to 20 pounds extra of weight for a child. So yes, TV watching might not cause obesity, but it's an important risk factor that we want to look at. So physical activity, which is an important component of energy expenditure. It's very good at preventing, perhaps, weight gain. It's not the cure-all for losing weight, but it is an important component. Here's a slide where we look at boys and girls, and what you see on this slide is the prevalence of participation in self-reported physical activity. I say self-reported because recall of physical activity among children is very, very problematic. Children who are not overweight are more likely to forget physical activities, whereas children who are overweight, they remember physical activities and they are more likely to report physical activities. But in any case, this is a potential measurement error that affects everybody equally. What we see is that boys are more likely to engage in more physical activity as they get older, whereas women or girls, actually, prevalence of participation in physical activity goes down as they get older. In this case, what I'm showing with you is trying to stay away from asking kids how much physical activity they do, but looking at the percent of students in each grade that actually participate in physical education classes. And as they get older, the percent of kids who participate in physical education goes down. It affects disproportionately Hispanic kids more than other kids. And that might reflect the fact that the schools that require PE are actually lower among Hispanic schools or kids that attend highly prevalent Hispanic schools than kids who attend highly demographic of white students. We're almost done. So in this case, this is an interesting slide because what we're looking at here is using accelerometry data. So this is not self-reported data. And what this is from NHANES. And what we found is that it confirmed the fact that as boys and girls get older, their levels of physical activity go down. We do notice that among Mexican-American boys and girls, they're actually more active. And that might be because they might take public transportation. They might do occupational work that is not reflected on the other groups. And why is that important? These are, theoretical perspective of three types of people: those who are sedentary, those who are active, and those who do not participate in leisure time physical activity. So I'm going to talk a little bit about people who do not participate in leisure time physical activity. And these are my two last slides. We do know that the percent of people who do not participate, this is no leisure time physical activity, is higher among Mexican American than it is for whites and for African Americans. And what is really striking, and I'll just leave you with this note, this is the prevalence of physical inactivity. This is not good. Among 20 to 29 Mexican American, these are Hispanic, but these are Mexican American men. This prevalence is higher than the prevalence of non-Hispanic white, 70 to 79. I'll repeat, let me show you this. This is the prevalence among whites who are 70 to 79. This prevalence of physical inactivity, you could put here heart disease, diabetes, whatever, it's lower than those who are Mexican American at 20 to 29, which makes this behavior is highly prevalent at very early ages. This is for men, and this is for women. This is the prevalence of physical inactivity among Mexican American women. It's higher than it is for 70 to 79. This is what I also call an inequity. Everything being equal, the prevalence should have been the same for these three groups. All right, that's my last slide. Obesity has increased, double or triple in many groups. Physical activity decreases as children get older. It impacts disproportionately Mexican American children and US adults. Thank you.
Thank you, Dr. Crespo. Now we have a few minutes for questions and answers.
Yeah, thank you very much. We have one question here in the chat. For children younger than 2 years, which charts can be used for overweight obesity diagnosis? CDC, WHO, BMI, or weight for length? C-scores or percentiles? If you can help us with this answer.
Yeah, I'll give you my opinion. I don't think it's everybody's in agreement. One of the challenges with children is adiposity is biologically not a huge predictor. If you saw the slides among Mexican American using the growth charts, I think I might be able to go back and show you that slide. Actually, there's a reason why I have. It hasn't changed that much. If you look at the slide on that I have here, let me see. Here we go. This shows that it hasn't changed that much. This is birth to 23 months. So I would say epidemiologically, I would use Z-scores. But if you're a clinician, a Z-score might not mean a lot. You do have those growth charts, and those charts are very useful because you can track height and weight. Here's another challenge. When a child is heavy, the bones respond to that extra pressure, and that child starts growing faster because you're adding some pressure to the bones. You're thinking, this kid, it's just going to be big. He's just big, and that's why he's heavy. At some point, puberty happens, and that extra weight continues to grow because you have to feed that extra weight, but your bones stop growing. And this is when you see adult obesity. When you are a child and you're just going by this chart, you're tracking and it says, yeah, weight is going up because height is going up. But again, the bone is responding to the extra force that extra weight is putting on them. So to answer your question, I would look very carefully at these growth charts, especially that the CDC has put together. They have been updated. They were done primarily with US children. And because US children have high rates of obesity, they had to expand the number of kids that are informing that growth chart. So they have had children from all over the world. I find them to be valid in terms of being able to monitor. You do also want to make sure that you don't completely go by this height weight, because again, the bones are responding to the extra weight.
Okay, thank you so much. I don't know if we have another question from the
Yes.
QI.
Yes, there are several questions.
Okay, yes. Yeah. What intervention strategies can be used for Mexican American Hispanics who might not eligible for government-sponsored coverage interventions?
Yeah, good question. You know, I personally think, I mean, I'm a public health person. We're not going to solve this problem at the doctor's office. You know, first of all, they have not been trained to deal with this. A few doctors are trained, but for the most part, this is a very a condition that responds highly to policy and environmental factors, and that requires policy, and that is not exactly something they teach you in medical school. So I personally think it has to do with, for example, if you think about if you think about how many times we walk to school, I have a couple of slides. So here is an example of a policy. In 1969, we used to walk to school. In 2001, we walked less to school, even walking a mile to school. And what we know is that our kids, especially Mexican American kids, are more likely to walk to school. This is 12th grade, this is 10th grade, and this is 8th grade. This is percent of students who walk to school. These are small things that we can do environmentally that might increase physical activity. Again, physical activity is not going to make you lose weight, but it helps you prevent weight gain. There's the other part, what we eat and how much exposure our kids are getting to junk food. And I think during the day, we're going to have speakers that will talk about that.
Yes. Let me see. So somebody's asking about the relation of obesity and exercise, but what about food?
Yeah, I think that's the key. I mean, you cannot exercise yourself out of a Big Mac. A Big Mac, it's, I don't know, 800 calories. And if you run half an hour, you burn maybe 300 calories. So the delta there is against you. it's very useful. I wish we would talk about physical activity as a healthy behavior that has nothing to do with weight. It is related to energy expenditure, but it's more about the easy access to calories. And more recently, I've been looking at these ultra-processed foods. The easy access to ultra-processed food at very, very young age. And that makes our palates actually seek those kind of food. And that's, again, that goes back to policy, goes back to what we serve in the cafeterias, in the schools. And the other part is we're in the US, for example, the percent of our income that goes to buy food is one of the lowest compared to other nations. We need to buy better quality food and teach our children early how to enjoy healthy foods.
Thank you very much. That's all the time we have for questions. Please, Dr. Crespo, you can answer the questions. There are many questions in the chat. We will appreciate that. Thank you so much. So we will move forward with the next presentation. Dr. Sofia Moran Ramos, please.
Do I exit here? Let's stop share. There we go.
We cannot hear. No.
You're muted.
Can you hear me now?
Yes.
Okay. Thank you. I think my headphones were not working. Let me just go back. Okay. So thank you very much. Hi to everyone. Thank you for the invitation to this awesome webinar. And today I'm going to speak on the role of the gut microbiome and its metabolites in children's metabolic health. So I am a food chemist, but I have the later be trained in food science and human nutrition, and I have a PhD in biomedical science. And now I'm working at the lab that is a joint collaboration between the National Institute of Genomic Medicine and the School of Chemistry of UNAM. And there we do research on how the gut microbiota could contribute not only to obesity, but also to the presence of metabolic alterations. So Dr. Crespo already gave us a very good scope of what is the prevalence of overweight or obesity in Mexican population living in the United States. And of course, this is not very different from what we actually see in Mexico. As you can see here, the last National Health and Nutrition Survey showed that 37% of school-age children were either overweight or obese. And of course, he already had said that it is a multifactorial disease where environmental factors plays a very important role. But we do think that all these environmental factors, including diet, are able to modify the gut microbiota and therefore change the way people increase weight or children increase weight and develop metabolic complications. So with this in mind, if you look at the gut and the intestine, I like to show this slide because it really shows that everything that we eat and everything that is within the gastrointestinal tract is able to be utilized by the gut microbes. So and this utilization of the metabolites that they produce, they are able to pass through the intestinal barrier or to be absorbed into the circulation, and then they can reach different or distant organs, such as the liver, the brain, the adipose tissue, and therefore have a huge impact in metabolic health. And with this in mind, one of our most recent questions was, what was the role of the gut microbiota and their metabolites in the development of metabolic complications in school-age children? We have been able to work with a great cohort of school-age children here in Mexico City. And a few years ago, when we analyze certain metabolites, such as amino acids, we were able to find that an amino acid signature composed of brain chain amino acids as well as other amino acids was able to predict which children were going to develop hypertriglyceridemia 2 years after. Of course, this is related also to insulin resistance, but what we wanted to know was whether the gut microbiota was involved in this increase. And particularly because even though branched chain amino acids are essential amino acids and are thought to be their main contribution is through the diet, a few years ago, there was a proposal that also the gut microbes were able to synthesize these amino acids or even utilize them and therefore impact the circulating levels of these amino acids. So in one of our works, we actually wanted to see whether the bacteria that were living in the gut were able to produce them or not. So we searched for the genes that were encoding these metabolic pathways, and we did correlations with the circulating levels of these amino acids. And as you can see here, we found no particular correlation with the genes that encode the biosynthesis of these amino acids. But we observed, and this is a heat map that actually showed the correlation estimates, we see a nice negative correlations between circulating levels of amino acids and the abundance of genes that encode for transport or inward transport of these amino acids. So what we think that can make or may be happening is that these inward transport systems, or the bacteria is able to uptake these amino acids, and by uptaking these amino acids, then these are not bioavailable to their absorption into the gut, and therefore contributes to modulating the levels of these amino acids in the circulation. And so our next question was whether a specific taxa or a specific bacteria was able or was contributing to this function. And what we found here was, and you may have heard of it, we observed or we identified Faecalibacterium prausnitzii as one of the key bacteria performing this function. As you can see here, we did correlation between the abundance of these bacteria and not only branched chain amino acids, but also a marker of insulin resistance. And we observed a negative correlation between levels of these amino acids, abundance of these bacteria, and the levels of branched chain amino acids and insulin resistance. So what we and others have proposed in this sense, as even though Faecalibacterium prausnitzii has been already known for a lot of years because it has anti-inflammatory properties, it's part of the natural gut microbiota, maybe it has a function of uptaking the amino acids, and by uptaking them, they are prevented from absorption into the circulation, and therefore could this contribute to the lower insulin resistance observed in the children? That's where we are still working on. But an interesting question for us was whether through the diet or if there was an association between dietary components and the abundance of these particular bacteria. And so through dietary analysis, we observed an association of legumes consumption and the abundance of these bacteria. And as you can see here, we stratify the children by quartiles of legumes consumption. And even though it's not a big effect, you can see here that those children that are in the top quartile of legumes consumption, which means 4 portions per week, have higher level of this or higher abundance of these bacteria. And this was actually reproduced in an independent cohort of school children, also from Mexico City, but where we actually see that the 4th quartile, which corresponds to 4 portions per week, have greater levels of Faecalibacterium abundance. So of course we are continuing this research to actually show what will be the role, and if by modulating the abundance of particularly these bacteria we can contribute to insulin resistance or prevent insulin resistance. But that's a thing that we are still working on. So the next question was if the gut microbiota could contribute not only to insulin resistance, which is a key factor in the development of metabolic syndrome, but also to the presence of metabolic syndrome through its metabolites. So for this, we focused on bile acids. And the reason why we focus on bile acids is because they are indeed produced in the liver, but then they are excreted or they are secreted to the intestinal lumen, where bacteria transform primary bile acids into secondary bile acids. And what has been known for a while is that these bile acids can be reabsorbed into the circulation, and they have multiple effects, multiple metabolic effects within the liver, within the adipose tissue, and other distant organs. And interestingly, almost a decade ago, some research showed that higher levels of secondary bile acids, particularly deoxycholic acid, was associated with insulin resistance and with type 2 diabetes in adults. So for this, we did this comparison analysis with children with and without metabolic syndrome, and we searched for bile acids that were different among these children and whether the microbiota was related to this difference. So I'm going to show very quick our results here. And here you will have a discriminant analysis where the deoxycholic acid is the main metabolite that discriminates between children with metabolic syndrome and without metabolic syndrome. And particularly deoxycholic acid is increased in those children with metabolic syndrome. And as you can see here in the heat map, this deoxycholic acid correlates with HOMA as a marker of insulin resistance, but also with other markers such as the triglyceride to HDL ratio. So this goes well with the literature that shows that the production of this type of bile acids or the presence of this bile acid could be associated with a metabolic dysregulation. But then we wanted to search for interactions with the gut microbiota. So we were expecting to find positive correlations to search for bacteria that could be responsible for producing these secondary bile acids. And instead, what we found, and this is a heat map showing correlations between circulating bile acids and the abundance of different bacteria. And unfortunately, we didn't find any positive correlations. And instead, we find negative correlations with bacteria that had been reported to be beneficial bacteria, such as Bifidobacterium or Akkermansia, or even Fecalibacterium, which I showed you before. It is an anti-inflammatory bacteria and probably it's able to internalize those parenchymal amino acids and prevent them to be absorbed in the circulation. So what we see here is that the perspective is not that easy, and there is an interaction between bile acid and gut bacteria where we think that the bile acid dysregulation that is a result of insulin resistance could actually be contributing to the gut microbial dysbiosis, the alterations in the gut microbiota composition that occurs in these children with metabolic syndrome. And with that, I want to finish just with the take-home messages that I think that are important. Fecalibacterium prausnitzii could help in the modulation of circulating branch chain amino acids, and in this way to insulin resistance. Of course, we need a lot more studies to prove that probably dietary intervention could be a potential strategy to modulate Fecalibacterium prausnitzii abundance and well as their diversity, and that insulin resistance can contribute to bile acid dysregulations, and the latter may influence gut bacterial dysbiosis. And with that, I want to thank to all the members of population genomic units, and that this is the joint lab between the School of Chemistry and National Institute of Genomic Medicine, that without them, this work would really not be possible. Thank you very much, and I would be happy to take questions.
Thank you, Dr. Moran Ramos. We are going to have questions and answer session after the end of the block. So we will listen to Dr. Claudia Tovar and Dr. Sharon Donovan, and at the end we'll have questions and answers. Thank you. So.
Okay. So can you see my screen?
Yes.
So, good morning. I am Claudia Tovar Palacio, and I am a medical researcher at Instituto Nacional de Ciencias Médicas y Nutrición, Salvador, Zubirán. I earned my PhD at the University of Illinois, where I developed my passion for nutritional science and its impact on metabolic health. My research is focused on metabolic disorders, particularly the interest between obesity and diabetes. I am studying how diet and natural substances can influence these metabolic conditions. Recently, I initiated a study to understand the complex relationship between childhood eating habits and the onset of obesity and diabetes. So, let's talk about obesity. Obesity is defined based on the body mass index. For adults, a BMI over 30 kilograms per square meter is considered to be obesity. So, obesity is a widespread issue in many parts of the world. In fact, the number of people with obesity globally has now surpassed the number of those who are malnourished. This map shows the global prevalence of adult obesity as defined by the value I mentioned. We can observe that the values are quite high in Latin America. This is just a brand new map. And remember, we are just talking about obesity here. If we include overweight, the numbers would be even higher. Specifically, we are looking over rates between 20 to 30%. So, our symposium focused on the widespread issue of obesity among children and teens, a challenge that extends beyond the adult population. We determine obesity from an epidemiological standpoint, child obesity, using the BMI, which is adapted for each age and sex to reflect the changes in BMI that undergo during growth. A recent study by Lister and colleagues highlights the significant occurrence of these conditions in boys in Latin America. For girls, the prevalence is particularly high in Mexico. According to the World Obesity Federation in Mexico, 44.5% of boys are living with overweight or obesity, and 41.4% of girls. This map illustrates the global body mass index change from 1985 to 2019. The color coding shows an increase in BMI. This trend is escalating. BMI is observable across various nations. In boys in Latin America, as you can see here, and in Mexico, it is particularly high in women. So far, I have referred only to overweight and obesity in general. But I believe that we must increasingly consider severe obesity. The severity of obesity in children is associated with an increase in cardiometabolic risks. In this case, few studies analyze severe obesity. You can see in this table by Moreno that it is important to remark that severe obesity in children varies by definition and country. For example, in the United States, the prevalence is ranging from 1.9 to 6.3. And studies show that the obesity values increase by age, emphasizing the necessity to unify diagnostic standards. In the case of Mexico, there is little information. In a study conducted in 2007, which took place in the north of the country, a prevalence of 5.2% was identified. But our focus is on childhood overweight and obesity. So it is essential to have a model for examining this issue. We will explain the model by González, Muniesa, and colleagues, which covers the period from conception to 18 years and outlines how certain factors are shown at the base of the figure can condition the development of obesity in a person, such as genetic factors, behavioral, such as diet, physical activity, and socioeconomic factors. Additionally, during this span, there are 3 critical points. First, key developmental milestones occur in the initial 1,000 days from conception through the secondary year of life. Second critical period is around 5 years, all when the adipocyte rebound occurs. It can lead to an excessive when the adipocyte rebound occurs prematurely, it can lead to an excessive accumulation of body fat. Subsequently, the third critical period is during puberty or adolescence. In this period, risk factors are identified. And several of these are shown here, like high maternal BMI, early adipocyte rebound, and so on. So, in our approach to studying children's health and growth, it's crucial to expand our focus beyond just the first 1,000 days after birth. We must adopt a comprehensive strategy covering the entire span of the first 8,000 days of child's life. In addition, crafting target health interventions during middle childhood can further enrich the extensive investment in educational systems. Tailoring educational programs to address health can significantly enhance the well-being of children. Over the past 15 years, neuroscience evidence suggests that the critical phase of brain development occurs beyond the first 1,000 days, and in some cases, longer after. By age 6, here, the brain has reached approximately 95% of its adult volume, but the size is not everything. Rather, the connections within the brain are growing importance through middle childhood or adolescence. By development during infancy and early childhood is marked by the development of primary cognitive and emotional abilities. With the onset of hormonal changes of puberty in middle childhood, a new phase of brain development commences in which the individual's interactions with the social, cultural, and educational environment shapes the process of myelinization and synaptic pruning of centers involved in emotional processing and higher executive functioning. Brain development during these years primarily focus on acquiring higher level cognitive, emotional, and social skills essential for functioning in complex systems, and most importantly, creating habits. So, obesity is a chronic disease with complex contributing factors. Childhood obesity results from a multifactorial set of socioecological, environmental, and genetic influences that act on children and families. So I will focus on studies that analyze these factors in Mexican children's middle childhood around 5 to 11 years. So let's start with environmental factors. The rise in obesity is linked to the availability of high-calorie foods, large portions, increased consumption of sugary drinks, and a sedentary lifestyle. In a study based on the Instituto survey conducted by Shama Levy on 1,581 school-age children, it was found that children consume more added sugars than the 10% recommended by the WHO. Children use more electronic devices such as TV, tablets, phones, leading to less physical activity and bad sleeping habits. Their bodies burn fewer calories and they tend to eat worse. This is a big reason why more children are developing obesity. This slide summarizes findings from the 2022 Instituto Continuous Mexican Survey on adherence to recommend guidelines for physical activity, sedentary behavior, and sleep among children. It indicates that only 31 and 15% of children meet two distinct physical activity guidelines, and 17.8 adhere to the recommendations against sedentary behavior. For sleep guidelines, 32.2 comply. What about genetic factors? Genome-wide associations study for obesity have identified multiple single nucleotide polymorphisms, SNPs, in populations of Europe, East Asia, and Africa ancestry. The contribution of this lossy to obesity in Mexican children is unclear. In a study conducted by Liu and colleagues, 17 obesity lossy with significant association with these conditions were found. And through more detailed mapping, 5 of these lossy show an even stronger association than those identified in the original GWAS. Additionally, deviations were observed in 6 obesity-related SNPs that differ from expected models, highlighting a notable interaction that affects the risk of obesity between 2 specific genetic regions. Regarding social factors, parenting styles have a significant impact on children's risk of obesity. Authoritative parenting, which balance high expectations with responsiveness to a child's needs, is associated with healthier eating habits, increasing physical activity, and lower rates of obesity in children. In contrast, permissive, authoritarian, and neglectful parenting styles are often linked to higher obesity risk due to less healthy eating patterns and lower physical activity levels. Understanding these dynamics is crucial for developing effective interventions to promote child health. In a study conducted by Montiel Carvajal, investigated mothers' parenting styles. The study included 58 mothers and their children ranging from 2 to 8 years old. The purpose of this study was to understand if parenting styles differ in families with children who have obesity compared to those with children in normal weight. No statistical differences were found in parenting styles between the 2 groups. So, as a conclusion, let's synthesize our insights with the 10 top strategies in preventing childhood obesity. This integrative approach considers the full spectrum of factors impacting a child's well-being. We recognize the importance of environmental influences like the availability of green spaces for physical activity, and understand the socioeconomical factors such as family income directly affect the nutritious foods. Genetic predisposition plays a role, yet policies and systems can have the most leverage by ensuring healthy food options in schools and shaping healthcare system to prevent and treat obesity efficiently. Our behaviors and lifestyles, including diet, exercise, and sleep, are key areas of focus, while psychological aspects like our relationship with food and body image are quite crucial. Finally, the social and cultural milieu, from family influences to peer pressure, shape our food and exercise norms. Addressing childhood obesity is complex and multifaceted. By approaching it through these 10 strategies, we can create a supportive environment for our children to thrive. I would like to finish by thanking Dr. De Mejia and Dr. Kaufer, and thank you all for your engagement and dedication to this important cause.
Thank you very much, Dr. Tovar Palacio. And the questions will be answered after the next speaker. Dr. Sharon Donovan continues. Thank you.
Okay. All right, can you see my screen now?
Yes.
Okay, so thank you very much and good morning to everyone. I will be, I think, really building upon the presentations we've just seen. So it's hopefully some of the data that we have from our Strong Kids cohort will build upon, for example, the last two presentations in particular. So my name is Sharon Donovan. I'm a professor and Melissa M. Knoll Endowed Chair in Nutrition and Health in the Department of Food Science and Human Nutrition. And I also direct the Personalized Nutrition Initiative. And my research is focused predominantly in factors in the first 1,000 days and how nutrition is interacting with environment, for example, to shape microbial, immune, and cognitive development. So why think about the first 1,000 days? Again, we've all are familiar with the DOHAD hypothesis that suggests that this is a very critical time for programming long-term health, and for the sake of this presentation, focusing on growth, metabolic regulation, and obesity risk. And many studies have shown that this really represents a unique opportunity. But if we think about the research that's available, much of it has been done in animal models, and much of it has really focused on what's going on in pregnancy and not nearly as much in lactation and toddlerhood. And if you think about this, this represents 2/3 of the first 1,000 days. So my research focuses a lot on human milk and infant formulas and breastfeeding and lactation. And why is this important? I think this is a wonderful quote from Cesar Victoria, who states that human milk is not only a perfectly adapted nutritional supply for the infant, but probably the most specific personalized medicine. And we know that nutrition is important, but human milk contains many bioactive components and non-nutritional components, such as human milk oligosaccharides, which shape the microbiota and shape development. The other aspect is, if we can understand the timing of factors that are associated with the risk of childhood obesity within this first 1,000 days, we can then direct specific interventions targeting these different phases. And as you can see in this factor, it's very important to consider pre-pregnancy effects, as we know in many countries, including Mexico and the US, that many women of bearing age are overweight or obese, and as that is putting them at higher risk for things like gestational diabetes and excessive weight gain, and increasing their child's risk of obesity. So I'm gonna see if I can, I don't know, I'm trying to hide that thing at the top. So I think as Claudia was just talking about this idea that we really need to think about very holistically about the risk factors for obesity. And this is a socio-ecological model put forth by the Centers for Disease Control. And you can see that it starts with the individual, works with family and peers, childcare and school, community, built environment, society, and ultimately public policy. And this was published in 2022. Back in 2011, we published what we call the 6 C's model for our strong kids. And it's called 6 C's because every part of the model begins with C, but you can see that it mimics very closely this idea of going from the cell or the internal biological factors to child, plant, community, and country. So if we dig a little bit deeper, we see some of the factors that we're studying within the 6 C's model. So for the cell, we're looking at SNPs. We're also now looking at epigenetics and microbiome. A lot of the work in child is focused on their dietary intake, self-regulation, physical health. When we look at the clan, again, this is looking at how the family is functioning in terms of diet, feeding practices, physical and mental health, and household organization. Then the community, we're looking at child care usage and economic strain on the family. Country could be related to WIC and SNAP and media, and then society, predominantly cultural norms. So again, this is a very simplistic relationship as we look at these interactions for childhood obesity. And again, a very simple model would be that dietary intake is associated with childhood obesity. We know from an energy balance perspective, obviously, that energy expenditure is also influencing the risk of obesity and overweight and obesity. We're also very interested in, we have members of our research team looking at behavior, which could be affecting temperament, eating, and executive regulation or executive function. Because of Dr. Turan Garcia being on our team and others, we're also interested in, well, sorry, this is more my area. So we're looking at the microbiome. We can see how dietary intake influences the microbiome, and the microbiome is associated with childhood obesity, as you heard in a previous talk. We're also, again, with work with Dr. Turan Garcia, looking at genetic regulation or genetic variation through these SNPs. And then lastly, we're also in collaboration with Dr. Pan looking at epigenetic variation and how that could be associated. So, but remember, all of this is then also encapsulated in the environment in which this child lives. So I'm going to talk to you about our Strong Kids cohort, Strong Kids 2, and this stands for the Synergistic Theory and Research on Nutrition and Growth. This is a longitudinal cohort that we've been, we started with 450 mother-infant dyads, and our first measurement was at the child's 1 week of age, and we've been following them through 7 years. And we just received a new NIH grant that started March 1st that's going to allow us to continue to follow these kids to 10 years of age. And I think what's really unique about the Strong Kids cohort is it really does integrate the individual biology, the cell factors we talked about, with the family environment, with a predominant focus on healthy eating habits and growth trajectories. So we have many time points. You can see we do a lot of sampling in the first year of life, 1 week, 6 weeks, 3 months, and then 1 month after the introduction of solids, and then 1 year, and then 18 months, and then annually thereafter. And because our team is very multidisciplinary and goes from nutrition through human development to kinesiology, we have very broad surveys that age up with the children in the families. So we have surveys that have looked at nutrition practices, daycare practices, family meal times, physical activity, media exposure, sleep patterns, and attachment. And then the survey data is coupled with biometric measures. So every one of these time points are actually home visits where we have undergraduate students who go into the home, collect length or height and weight at every time point. We've collected stool samples from the child at every time point, and the mom at 6 weeks postpartum. We collected saliva samples from the mom and child at 6 weeks to extract DNA to look at SNPs and epigenetics, but we also collected another sample from the child at 4 years so we can look at epigenetic changes that have occurred between 6 weeks of age and 4 years of age, and then relate that to our child outcomes. If the mother was breastfeeding, we also collected a human milk sample. We also measured milk intake from using 24-hour weighing. As the children got older, we incorporated bioelectric impedance measurements, again, on the mom and the child. And then we also are using a veggie meter to get an assessment of carotenoid intake. So again, with the heights and weights, we're calculating BMI, BMI Z-scores, weight for length, and growth trajectories. Human milk, we're measuring, again, intake, but also milk composition, including human milk oligosaccharides. For the saliva, extraction of DNA for genetics and epigenetics, the stool measurement of microbiome and metabolome, and again, body composition. We have brought some of the kids to Dr. Naman Khan's lab for DEXA as part of a sub-project called Bright Kids. So we have both bioelectric impedance and DEXA, and again, the skin reflectance spectroscopy. For the sake of time, I'm just going to be focusing on growth trajectories and microbiome today. So this shows the demographics of our parent and child. Again, this represents a Illinois population, but also centered around the University of Illinois. So you can see that our mothers are quite educated. About 73% have college or postgraduates, around 31 years of age, but our range was actually 18 to 42 years of age. You can see we have about only 4.1% of the cohort of our 450 families are, the moms were Hispanic Latino. So unfortunately, we don't have a huge representation of Hispanic Latino families in our community. What's interesting, though, even though these mothers were quite well educated, we found that pre-pregnancy, less than 50% of them were actually of a normal weight, and 50% were either overweight or obese. So we know that those are risk factors for childhood obesity. For the children, we see they were exactly 50% male and female, around 40 weeks gestation. Around 25.5% of our babies were born by C-section, which we know can influence microbiome and other health outcomes. And we see fairly high breastfeeding rates. So at 1 week, 70.5% were exclusively breastfeeding and 21.6% were getting combined, so both breast milk and infant formula. This shows the pattern of infant feeding over the first year of life. So you can see what I just showed you in terms of only less than 9% of our babies start as exclusive formula feeding. But then over time, we start to see that more babies are moving into that category, and we see a drop in exclusive breastfeeding after 3 months. But even at 12 months, almost 50% of our babies were still getting exclusively breast milk. And then by a year, about 14% were already introduced to cow's milk. So while I said exclusive breastfeeding, that we do see introduction of complementary foods on average around 5.5 months of age. So this is actually recent data that we're working on and we'll hopefully be publishing soon, where we looked at using BMI Z-scores. We're also doing this for weight for length Z-scores. This is based on WHO, but as in response to an earlier question, we're actually also mapping based on CDC scores, and we're actually looking at what's recommended in a clinical setting in which children are mapped using the WHO growth curves until age 2, and then they get moved to the CDC growth curves. And because these are generated from different data sets, there's not a smooth transition. So in the ultimate publication, we'll have our strong kids mapped on WHO, CDC, and the sort of transitional, and looking at both BMI Z-score and weight for length Z-score. So basically, you can see different patterns too that we're calling low because they're below the score of 0, so below the 50th percentile. This group in the gray, you can see, has a very sharp increase in weight gain between 3 months and 12 months of age in particular, whereas the low stable stays much more. Their increase only goes to 0 Z-score. Then there's 2 other groups that start above 0. This group we're calling high stable, and then this group again is high increased. And so we're really looking at these 2 patterns. So if you look here on the right, the groups that are increasing in particular, and if you see the green, these are the kids who at 5 years of age, this is what their weight status is. So in these, the blue group, the high increase, you can see that almost 50% of them are actually in the obese category. And the majority are overweight. We only have only around 22% who are in a healthy weight. And you can see this too, even though this group started low, because of this higher weight gain, our rate of weight gain during this critical time, we are seeing more kids in the overweight and obese categories. So we started looking at what are some of the factors that might be influencing this. And so I'm going to show you some of our microbiome data. So because we had 10 samples, so this is just through 5 years of age, but we had up to 10 samples for each child over this period of time. And so this is what's called a principal coordinates analysis. So if you start up here, you see these in the brown are each dot is a different infant. You can see 1 week of age, 6 weeks of age, 3 months of age. The blue is introduction of solids, 1 year. And then they're at this point at 2, 3, 4, 5, they're sort of getting closer to the mom, and the moms are shown here. And so this shows a very nice transition of the microbiome composition from 1 week of age to 5 years of age. And again, statistically, by 4 and 5 years of age, they were not different from the mom, but they still were at 2 and 3. So in the literature, a lot of papers will say children have an adult microbiome by about 2 years of age, but we're actually seeing that it's taking a little bit longer, and other papers support that as well. So this was another way that we looked at how this transitioning of the microbiome. So this is called a DMM modeling, and Christopher Stewart had a very nice paper back in 2018, which took this approach. And so what you see, these are the postnatal ages at the bottom. And basically you are able to divide them into 3 different sort of phases of progression. So these are the earlier, the phase 1 is the developmental phase, the transitional phase, phase 2, and then the more stable phase. So as I mentioned, around 3 to 4 years of age, they're moving into a stable phase. And then we looked at, well, what were the top 3 genera that were driving membership in each of these DMM clusters. So you can see these early time points, bifidobacteria is actually not as that predominant in the very young infants. And then you can start to see that Streptococcus and Escherichia shigella start to go away. You start to see bifidobacterium be more predominant, but also Blaudia faecalibacterium as well. And so we can see these transitions. So one of the questions that we had was, what are the factors that are associated with a higher weight gain trajectory? And we're actually looking at all these different trajectories, but we're focusing on, the high stable and the high increase, because both of these groups started at about the same Z-score at birth, but then it was the rate of this rapid weight of gain, which again led to a Z-score of a little over 2 versus the kids who were a little bit heavier but were relatively stable. And, you know, consistent with other literature, we're finding that the ones in the high increase, they're had lower exclusive breastfeeding, lower duration of breastfeeding. We also found that their Shannon diversity at 1 week and 3 months was greater. So this is the a measure of alpha diversity in the gut. And what was very interesting, and again, this is consistent with other reports, for example, in the child cohort in Canada, that one of the factors that was very clear is that these children in this high increasing, very rapid weight gain, were actually getting an earlier colonization with firmicutes, and particularly Ruminococcus navis, Glaudia, Clostridium inoculum, and Lactospiraceae. So, and we know these are associated with formula feeding, so likely the lower exclusivity of breastfeeding, duration of breastfeeding is driving changes in the microbiome, which is then being associated with the growth rates and the growth trajectories. So in conclusion, personalized nutrition within the first 1,000 days is really underexplored, but it's such an important time for setting long-term growth trajectories and health trajectories. Our Strong Kids 2 longitudinal cohort provides an unprecedented opportunity to explore the potential drivers because we're able to combine the biological factors within the child along with the environment, the family, and as well as the broader environment. Again, breastfeeding practices and microbiome diversity and composition influence trajectories, and we believe human milk components are driving some of the microbiome differences. My lab studies the human milk oligosaccharides, so we have HMO composition of all the mother's milk, and we're investigating that. And with our new grants, we're able to now do more analysis of the genetic and epigenetic factors, not only in the mother, but also in the child. And then ideally, the final aim of the grant is to start to really apply the personalized nutrition approach, where we'll take all these multi-omic samples, so microbiome, epigenetics, and genetics, and use machine learning to hopefully help us to identify predictors of growth in early life and risk of childhood obesity. So this is really a large team of investigators. We have participants that have been with us now for 7 to 10 years. And so, and particularly even through COVID, it was amazing that we have so many sort of loyal participants. We've had a series of wonderful program coordinators, postdoctoral fellows, graduate students, and particularly the undergraduate students who are doing all of our home visits and interacting with the families. And so as you can see, the investigators predominantly from Human Development and Family Studies, Kinesiology, Community Health, Extension, and Food Science and Human Nutrition. And also like to thank our funding sources. The cohort has actually been funded through the Dairy Council, but we've been able to augment that base funding with grants from NIH, USDA, Gerber Foundation, and the Food and Family Program. So thank you very much, and I'll look forward to any questions during our next session. Thank you.
Thank you, Dr. Donovan. So we will have now time for questions, and Dr. Marta Kaufer is the moderator. Thank you.
So thank you very much. We're a little bit behind time, but thank you, Sophia, Claudia, and Sharon for your wonderful presentations. There are lots of questions. I see in the chat, in the Q&A chat, that some have been answered by Dr. Moran, but still there's a lot of interest in the probiotics issue here. So maybe you can summarize all the questions with regard to probiotics. The use of probiotics in children, are they recommended? Are they not recommended? Which probiotics or when? I would ask the speakers to be brief with the answers so that we can take a short break after the Q&A. Thank you so much. So Dr. Moran?
Yes, sure. Thank you, Marta. Well, as I was saying in some of the questions that were raised in the Q&A chat, I do believe that probiotics are well recommended for intestinal particular pathologies, But so far for metabolic health, I wouldn't believe that there is a particular probiotic that needs to be supplemented, you know. There is no enough research for obesity or even metabolic alterations. The gut microbiota for us has been an amazing path, you know, but we do think that we are still in a very preliminary set of the research. So I would say that probiotics are recommended for particular intestinal pathologies, or even, for example, probably fatty liver disease, which is more or less documented. But so far, there are no evidence of a specific species such as Saccharomyces or even Faecalibacterium through the ingestion of probiotic that they could have a benefit in children. And this is particularly interesting because we do need to remember that the gut microbiota of children is still under development. So the effect that can have in an adult a probiotic could be very different of the effect in a kid. And with that, I think it's a very good summary.
Thank you so much. Yes, it's a huge topic nowadays for children, for adults, for different metabolic diseases, use of antibiotics, whatever. So, Dr. Claudia Tovar, somebody asks how to convince political actors to intervene in educational systems. Do you have any idea how they can intervene?
Yeah, I think that's a great question. I think it is a great opportunity that we can combine this education in health and nutrition and the educational school system, because it's already set up in, the school. But we need to be very careful with the programs. We need to really know how to teach this type of information, especially focus at the level of the children. I think they don't need to know very high level information about nutrition. They just need to know what is good for them with their language, with their I don't know, maybe play how to play with this type of information. Yeah, to be needs to be very specific for each level for the kids. Yes.
Yeah, I can maybe just add that
Yes.
some, programs where they've done, for example, school gardens, or, gave children exposure to different fruits and vegetables within the school setting has also been very successful. So I think with kids, particularly little kids, getting that hands-on experience, they like it. And as Claudia said, making it fun for them and age appropriate is really important.
Yes, and they need more tools than technical information. Yeah. So for you, Dr. Donovan, there's a very specific question on which program do you use to represent the PCA of microbiome from 1 week to 18 months. And then another question about if you consider that school programs are required where sports are implemented on a mandatory basis to help reduce obesity in children.
Yes, so we've used different programs. That was actually done in R, but if this individual would like to reach out to me by email, I'll be happy to provide more information. What we're seeing in the US, and not as much in elementary school, but certainly as we go to middle school and high school, because of the increasing focus on academic performance, we've often seen that even that sports have really been pushed out to maybe just once a week that they're doing it. And so one of the places where I think we can really intervene, as we talked about before, because we have kind of this captive audience within the school setting, I think it does go back to the question about policies. And there's a fantastic researcher who is at Illinois, Chuck Hillman, who did very an exercise intervention in 9 to 11-year-olds and found that through exercise and through increased fitness, they were actually able to increase the standardized test scores of the children. And so I think that's the kind of data that we need to provide to policymakers to say, look, it's not only good for their health, but it'll help them do better in school. And, you know, the same thing with weight status. I mean, Claudia talked about brain development. So I think that we have to make it compelling. We have to give them the why isn't important, because obviously they're not getting it in many places right now.
Yeah. Thank you very much. So we're over time. We don't have time for more questions, but there are lots of questions in the Q&A. I encourage the speakers to answer them because they're really very, very interesting questions. So thank you very much. And I leave you with Dr. Mejia.
Thank you, Dr. Kaufer. Due to time concerns, I'm sorry, we will not have a break, so we will continue with Dr. Margarita Terán. If you need to stretch, please do so, but we will continue with the program. Thank you so much. Dr. Terán?
Thank you very, very much. I looking for getting control of the slides, and I appreciate the opportunity to talk to you guys. Can I?
You should be able to share your screen.
Great. Wonderful. And you see my screen now?
Yes.
Excellent. Thank you very much for the opportunity to talk about our work. I'm Margarita Terán Garcia. This data we're going to be presenting, and thank you for the organizers to put this important collaboration of Mexico and the United States and Illinois system. This research that I'm presenting, the data, was supported by the National Institute of Agriculture to the Childhood Obesity Prevention Challenge area and was conducted in several regions of this country. I am Margarita Terán. I'm proud Mexican American, and I got my degree at the National Institute of Pediatrics as a pediatrician, and my other degrees at the University of Texas. And my work has been now to translate what we do in the university to practical terms as an assistant dean for integrated health disparities. I really would like to apply, and Dr. Donovan present some of the work I have been doing in genetics and environment and nutrition-related diseases to prevent childhood obesity. And some of my work is in this QR code that you can look some of my publications. What I really want to present today is how they set the stage of how the childhood obesity has been increasing year after year, has been worst over the pandemic, and how this rate has been affecting disproportionately Hispanic children. You can see these numbers are affecting more than 1 in 4 children and adults in the United States. Hispanics represent 18% of the US population. They are compared to whites in lower socioeconomic status. They have larger families. They have lower possibilities to have access to food. They have food insecurity is 18% in some of them. They have compared to 9% in white communities. Sometimes they have more insecurity to have access to places where to do exercise. Dr. Crespo was talking about the problems about exercise. And unfortunately, also the rates of Latino physicians and people doing higher education, and this is part of this collaboration that Dr. De Mejia and the institution is accessing to higher education is very, very important, is really limiting the access to healthcare systems. So what we need to do to prevent childhood obesity. This study represents a multi-site randomized controlled childhood obesity program that was culturally tailored for Mexican and Puerto Rican families. Why? Because 85% of the population of Hispanic origin are from Mexico or Puerto Rico in the United States. And we wanted to be tailoring this program for this type of families, having one child between the age of 6 to 18. We developed this program with 6 weekly sessions with nutrition education, family wellness, and physical activity. We wanted to adapt this curricula with topics across the country, and we were going from coast to coast, as I always think, from east to west and from north to south. California, Texas, Puerto Rico, Iowa, and Illinois. We wanted to adapt this curricula regionally with different cultural histories and social realities, and we were delivering this program in English and Spanish for families with mixed ethnicities and mixed culture, mixed status, and we wanted to figure out how to help these families because it was a real important need for those populations. And there are very few family-based programs with evidence of impact across the country. We have published this data about the methodology, and in that is the part I wanted to emphasize, that we are presenting just partially some of the data of this information. It's in an integrated approach that has a component of extension to facilitate and train professionals how to improve their outreach to Hispanic families, has the education and recruiting students who were the next generation of professionals who have training in cultural humility, cultural sensitivity, and have been the next generation of registered dietitians and medical doctors, people who will serve the communities where they live. And many of them first generation. We have more than 300 students that were participating in this program across the country. And in the area of research, we used a socio-ecological approach, as Dr. Donovan was mentioning, and with basis of the social cognitive theory that was implementing and evaluating the impact of the intervention. So this research strategy has two groups, the intervention group and the control group. The intervention group was receiving 6 weeks of the program. Everybody was measured at the beginning. At the beginning, they were assigned randomly to the intervention or the control. It was very important to create rapport with the families. Each one of the 5 sites was assigned to 100 families to evaluate, and then measure at the week 7 and at the 6 months of the intervention. Importantly, the families were teach the nutrition lessons, 30 minutes in Spanish for the parents, 30 minutes in English for the children, 30 minutes of family wellness in Spanish for the whole family. And instead of teaching about physical activity, they were doing physical activity together. So the meetings were according to the community needs in groups of 10 to 15 families, and also according to the community needs and the preferred day of time of meeting. So it was a very important and a colossal entrepreneur activity for everybody. We were teaching according to the dietary guidelines for Americans, principles of the My Plate, how to teach about the importance of nutrition education, about family wellness, about topics that are very important for the families, about how to the relevance of family meal times, sleep routines, avoid family conflict, but very important according to the traditions and the rituals of the families, how to maintain those traditions. And again, we give them the basics of physical activity, but they were doing physical activity during most of the time of the participation. The family-based workshops has a very basic element of linguistic situations of saying más de lo bueno, menos de lo malo. More of the good things, less of the bad situations of watching too much TV, being isolated, sugar-sweet beverages. And the recipe has reflective listening, empowerment, compromise, cooperation, the messages that I will do the following steps in a smart, small steps, practicing small steps at a time, and encouraging them to follow through their goals, their SMART goals, that weekly SMART goals. So we teach them how to eat healthier, practice every week. They were very happy to have a participation of all the members of the family. All were invited. The parents were always selected, which is the kid that worries more for you to be participating on this program. And that was the one who was measured, and everybody were playing bingo or loteria and doing physical activity together. So this data I'm presenting here is the efficiency of the family focus and intervention. And only I'm more focused about how we were directly measuring weights and height, as Dr. Crespo mentioned, to calculate BMI percentiles for the age and sex and the families. And we were doing other data about, diet behavior, physical activity, and other child eating behaviors. What we have, in the baseline is that most of the kids were age of 10. The BMI score was already 1.1. The BMI percentile, there was no difference between the intervention and the control. That has already 84%. So it's almost all of them were overweight. And you can see here, only 45% they have normal weight. Among the mothers, they were about 48 years old, and they have the BMI was already in 32.5 BMI index. Only 12% have a normal BMI normal, and they have most of them were born outside of the country, and they have low socioeconomic status and low education level. So this is important to note as the characteristics they have. You can see here that the proportion of children that they have been affected by obesity and in children and parents is higher than the national prevalence in before the pandemic. And the difference between the intervention and control groups is not statistically different. I want to mention that importantly is that those data, we have to halt our data collection and our project because the pandemic happened, and there were also issues with the hurricanes Maria and Irma in Puerto Rico. So those are limitations on reaching the 500 number that was our magic number to get in the original design. When we wanted to do this program, we also evaluate the eating behaviors, and we identified that the children who were participating in this program, after the intervention, they decreased the consumption of sugar-sweet beverages, French fries. Importantly, and there are very few programs that are family-based, increase the consumption of vegetables and decrease the fast food consumption. So we can see that out of the behaviors that we investigated, they have 3 unhealthy behaviors decrease towards the positive healthy behaviors, and they increase the consumption of vegetables. So it was a very important finding. Furthermore, we can see that in the weight status, you can see here is that the percentile 85 is overweight, 95 is obesity, and this is at baseline, the distribution of the intervention in yellow and the green in control of the BMI for boys and girls. And you can see the wide distribution we have, but you can notice that is the BMI percentile distribution of the kids that participated in the program. So this is a very high prevalence of not only obesity, but extreme levels of obesity in some of those children. By using BMI score to normalize the age difference and the range that we have, we can see that there was an impact of those children who had participated in the intervention. And that would be very simple to note and say, okay, this is a slight decrease and significant decrease in the BMI score. But what I want to mention that it was more important for us and to look into this table, and I will bring it just to your attention, how we were able to reduce, and this is, I want to spend 1 more minute in this slide. This is at baseline, the distribution of the kids. And you can see that children that participated in the intervention, and they were already obese, by the end of the intervention, they were able to move from the obese category to the overweight category, or from the overweight category to the normal weight category. That is very important because once obesity is established, it's very difficult to move from one category to another. Our program was designed to prevention, not to treat obesity. In order to manage weight in children, you need to have at least 26 hours a year of an intervention. This program only has 12 hours a year of intervention. Just keep that in mind. For the control group, once you have established obesity, it's very hard to move from one category of another. Just by providing some support and being part of the program, only 2 kids moved from the obese category to the overweight category. And it was very difficult to move some kids and to maintain in the normal weight category. In fact, 2 of them become overweight. So we can see that the movement, the shift of weight categories is very important and tell us that we were able to modify and to have an impact in changing the weight categories of these kids. So this is something that we want to take in notice, but the impact was beyond the body weight. This simple recipe was also affecting the parents after the intervention. Some parents were able to move the weight categories and decrease the proportion of parents that were in the obese category after the intervention, even though it was a slight proportion of children that they were in the overweight or obese category was very small. Those kids that participated in the intervention were able to modify their dietary and their attitudes towards exercise. This is an example of a kid that lose after 6 months of the intervention 40 pounds, almost 20 kilos, because he wanted to be part of the high school graduation and become a role model for the members of the family, for his younger sibling. And after several years of intervention, we know that they were moving from drinking 5 sugar-free beverages, 5 sodas a day, to drink 1 a week. That's a huge change and takes a lot of takes a village to make those changes. So they were receiving a very good feedback of the families that they were participating. They realized the portion size for the kids that they were serving over portions to the kids. They were forcing them to eat more than they needed, and we were able to transition during the pandemic to virtual workshops. We are still analyzing. It's a very complex data set because we don't have the amount of the number of participants in the virtual workshops. But it's important that generating this type of collaborations and having regional adaptations during and move to regionally into a virtual environment was important and was very good that we were able to do that type of transition. But most importantly, we were able to modify kids in their category. We see a higher impact in younger kids. We can see that this intervention in the diet quality, despite the brevity of the program, was impactful. And by doing this, we need to have more family-based approaches of the programs, and we need to approach the Latino as with priority to the Hispanic families. We need to figure out how to do more cultural adaptation to other cultures. Hispanic are not monolithic. We need to be sure that we do this type of programmatic adaptations. And I also want to be sure that we appreciate all the collaborations that takes a village, and these are all our collaborators in the other states that participate in this program. And we want to be sure that we keep moving on in the area of implementation science. These programs keeps adapting, and we are in the phase of implementation and dissemination. We can train others to implement the program. We have all the materials ready to provide it to others and train other trainers that they are ready to implement it. And we can figure out how to reach health justice, because this disparity is there are not enough programs that are adapted to Hispanic families and their realities. So if you have any questions, there are some manuscripts that we have here, and I'm ready to transition. And I was on time, Dr. De Mejia.
Thank you. Thank you so much, Dr. Margarita Terán Garcia. Thank you so much. Questions will be at the end of this block. So thank you very much. Now we have our keynote speaker, Dr. Simón Barquera, and he will start sharing his slides as soon as he's ready. So Dr. Barquera, welcome to the symposium.
Thank you very much. A pleasure to be with you today in this opportunity. And let me, oops, no. I am sorry. please let me know if you can see my slides.
Yes.
Yes.
Okay, thank you, Dr. Elvira. It's a pleasure to be with you today and with all the audience. Thank you for the invitation. And I will give a small presentation of the Mexican perspective on the obesity prevention efforts that we have conducted in Mexico during the last years, mostly from the National Institute of Public Health. Just to give you a very brief context, we have a 36.9% of adult obesity prevalence. In children, school-age children, 18%, and overweight and obesity in children is, in preschool children is about 7.7%. And this is the main public health problem in our country. We have more than 70% of the deaths from non-communicable chronic diseases, more than 140,000 deaths due to diabetes mellitus, more than 40,000 deaths attributable to sugary beverage consumption each year. And we are one of the highest consumers of ultra-processed foods worldwide, and it is costing us a lot. We spend more than 5.5% of our gross domestic products in health-associated costs to these conditions. And what is happening is that we have a food environment that has transformed over the years, and now it is very unhealthy. It is full of ultra-processed foods high in sugar, fat, salt, very directed with aggressive marketing to children, and with promotions, incentives to make these expenditures. And we have a long story of efforts to prevent and control obesity. We started characterizing this problem in the end of the 90s with the first ENSANUTS, the health and nutrition surveys. And since very early, we realized that we were increasing the prevalence of obesity in a very rapid way. In 2007, we have a collaboration that is funny, but the name of the collaboration is just the same name of this symposium. It was Obesity in Mexican and Mexican American Children, and it was a meeting organized by the National Academy of Medicine of the United States. And we make a report there and realized that we could do like front of package labeling, recommendations for hydration and to reduce sugar consumption. We started to talk about potential opportunities of fiscal measures like the soda tax, but in reality, it was until 2013 that the soda tax were approved. So that was our first success in obesity prevention policies. And maybe the second one was when we evaluated the soda taxes 2 years in a row in 2014 and 15, and then published the results. And after our good results, good impact of the soda taxes, more than 40% of the countries implemented similar measurements. And then in the 2020, we implemented the warning labels, and we banned the characters in junk food. And then recently, we have been having very good results. We just approved an education law that forbids schools to have junk food, but it's not only like a recommendation. It will have responsibilities for the people that fails that. And just yesterday, I am super excited because yesterday we approved our new food right to food law in Mexico by unanimity in the Congress. We had like 11 years trying to approve this law, and this law is not a solution, but it's a very good infrastructure to have a legal framework to make the state responsible of assuring healthy diets to the population, particularly the children. So this is basically what we have been doing. As you know, in Mexico, we have a lot of marketing, particularly marketing directed to children in very remote communities where there is poor access to water. And many people think that, okay, the problem is that there is poor access to water, and that's why these soda and products are there. But it's not a different problem. It's an associated problem. The these corporations and their power influence the policies. So we have not had infrastructure investment in water, in access to water, and it is related to the relation with these corporations. As I was mentioning you, in 2013, when the soda tax was approved, we had 2 years of evaluation, and we demonstrated that it was possible to reduce the consumption in 5 liters per capita per year. And this was one of the main success at their time in the world, because it represented hundreds of thousands of tons of sugar reduced in a country with just a very simple measure. The problem is that we consume 163 liters at that time. So 5 liters is huge for a policy win, but it's not much for what we need to do to improve the diets and to prevent obesity. We need to reduce more this number. We are not the first consumer of soda anymore, but we are maybe among the first 10 consumers of soda in the world. We also implemented a tax on junk food, and it was also evaluated, and we found a significant reduction in consumption of tax foods in urban areas after 1 year of evaluation. So it was a more modest result, but still important. Have a policy that reduces 5% the consumption of junk food compared to the counterfactual expected consumption. It was very important. So we, after the publication of these results, more than 40 countries around the world implemented taxes, and we now have more than 100 countries that have soda taxes, and this is very important. This is one of the most recommended interventions to improve the food environment around the world. The other one I want to talk to you briefly is the warning labels. In the left, you can see what we had before, the GDAs, which is a front of pack label created by the junk food industry, and it's very difficult to understand. It's misleading. It has a lot of information, but the information is based on 2,000 calories, and it's based on portions, and the portions are based on what the companies decide. So it's very difficult to interpret. We have evaluated that in Mexico, and not even 3% of the people understand it, and they cannot use it to improve their decisions. Instead of that, we decided to use these Mexican warning labels that are black octagons, and those are based on a system that was established first in Chile, but we choose more strict criteria based on the PAHO nutrient profile. So we have more strict cut points for calories, sugar, sodium, saturated fat, and trans fats. And in addition to that, we also decided to put 2 extra recommendations. That was not to give children non-caloric sweeteners or caffeine or products with caffeine. So this was implemented during the pandemic in the year 2000. And this is how some products look in Mexico. You can see, like in a can of Coke, 4 labels. And there are even products that have 5 warning labels, like those that you can see there. And it has created a massive reformulation in the country, because the companies, the junk food companies, don't want to have these labels in their products. The other thing that we have been able to do is to remove the cartoon character from junk food, and this is also very important. Also to forbid gifts and incentives associated with these celebrities or musicians or movie characters in products that have the warning labels. And this is also based on something that Chile made before, and that was working very well in that country. Now, we are often asked, what is the impact of this? We have been evaluating this for the last 3 years, following a lot what the companies are doing, and we have seen a massive reformulation of their products, but also we have seen that the population is now using the warning labels, and we in the national survey, when we asked the parents if they use it, 60% they say that they use it to choose products for their children and for them. 50% say that they have stopped consuming some products just because of the warning labels, and 45% say that they have a shift between products of a particular group thanks to the warning labels. In Chile, these warning labels were able to reduce consumption in about 30 calories in the population. So we did this modeling study in which we wanted to predict what will be the impact of these warning labels in Mexico. And we were estimating that probably these warning labels will reduce 36.8 kilocalories per person. And after 5 years of implementations, this will be around 1.68 kilograms reduced from the distribution of weight of the adult population. And that will be equivalent to have a reduction of 1.3 million cases with obesity and very important savings, $1.8 billion in costs. So this is a modeling study to predict what we think is going to happen. We still need to evaluate that, but the information about impact in Chile looks very well. So we are very positive about the potential of this policy. Now, what we have learned is that the main actor that is that you need that is a barrier to these policies is the food industry. And we have identified 4 categories of action against these policies. They call them the 4Ds, the World Cancer Research Foundation, which is to delay the policies. When you say we want soda taxes or we want warning labels, they say we need more time to clarify concerns, or we need more research to discuss this policy. We need to prove that it will have impact in the long term, or they divide. They say that there are other systems that are better, or they deflect. They say, for example, that it will have impact on employment and economy, or that it's a violation of intellectual property rights because they have their characters and they want to use it. Or they deny. They say the warning levels are not well understood by the population, or there's no evidence that marketing to children affects food preferences, these kind of things. So a lot of our work has been just to defend these policies from this type of narratives from the food industry. Food industry has created a number of organizations to support their interests, to oppose soda taxes, to promote auto-regulation, to promote the GDAs, or physical activity, and change the emphasis to solve obesity in other factors, no? So they love to say that the problem with obesity is a genetic one, or that is something that requires energy balance, these kind of narratives. And they often do not talk against the national policies by themselves, but they have created a number of industry chambers and organizations, and this save the burden of being against public health. They also have founded institutes and foundations like ILSI, or Alianza por una Vida Saludable, or Instituto de Bebidas para la Salud. These kind of foundations that talk and develop science or positions that are in favor of what they like. In the other side, we have a very good civil society that is organized around an alliance of healthy nutrition, and that is employing evidence-based policy recommendations developed by academia. They are, most of them are into the Alianza por la Salud Alimentaria. You can see some of them, their logos. One of the main actors is El Poder del Consumidor. Also Contrapeso, but as you can see, it's a very good and very big group of organizations that support evidence-based policies from academia. So let me show you some of the studies we have done to respond to these narratives. This is a study in which we demonstrated that taxes to the soda were not affecting the economy nor the employment. So you can see the trends on employment in the first graphic in the left, and after the implementation of the soda tax, there was no substantial reduction or something, an inflection point. And also in the changes in employment in commercial establishments, there was no reduction. So we have seen this in Mexico, we have seen this in Chile, and we are sure that that this kind of taxes do not affect the economy or the employment. The other thing they say is that there is more evidence needed to adequately implement a national policy. And here what we did is we created 3 expert advisory groups to support the policy design. One was with Latin American countries that had similar experiences in warning labels. Another one was with Mexican experts, and another one was an international advisory board. And we started to creating evidence and also discussing and making position papers to support the policy. And that was very important at the end in the discussions with the regulatory agency to pass the warning levels. But it's not only to pass the warning levels, it's to defend them in all the different organizations in which the food companies can block or can push back. So for example, in the World Trade Organization, when we approved the warning levels, the European Union, the United States, Switzerland, Costa Rica, and Guatemala, the governments say that the proposal restricts trade more than necessary. So the Mexican government wanted to stop this regulation because of this demand at the technical barriers to trade at WTO. We defended it with evidence, and we were able to survive to this. Also, the United States requested to give two more years to the implementation of the warning labels. And we also responded that we needed to implement the warning levels as soon as possible. And we were able to do it because there was a lot of social support from civil society organizations, many signatures from academia supporting the system. And this is also Nestle. There is a very interesting documentary from the public television of Switzerland in which they investigated how Nestle, through their government in Switzerland, tried to undermine the Mexico's anti-obesity policy. And this is all over the internet, so you can watch it. This is a full-page advertisement in the main newspaper, and this was paid by national experts from academia and from civil society organizations, all together, saying we want the warning labels, and we don't want to sacrifice this health policy because of trade agreements. So this was also very important in the negotiation of NAFTA to avoid this negotiation of affecting the warning levels. So this is what we have as the Latin American obesity prevention policy toolkit. As you can see, many countries in Latin America have implemented different policies in a very successful way. Just like 1 week ago, Brazil has approved a law. Chile has approved soda taxes of 25% and warning labels. Guatemala has approved warning levels now. So there is a domino effect in Latin American countries. Once a country is able to pass a good law and evaluate it, immediately all the information and the evidence is disseminated to other Latin American countries. And this is why many people around the world think Latin America has something special for interventions to modify the food environment. In what I think we have failed is in the conflict of interest. We need to have a very good system to stop industry interference in this the development of these policies. And we also need to improve our efforts to promote the food system transformation, because obesity is a very complex disease, and we really need interventions that are structural and that are not only from the health sector, but from the economic sector, agricultural sector, education, etc. So what is very positive now, and I think this is something that is making us feel very optimistic is that in the last years, we have been able to organize a very important group of civil society, legislators, government officials, and academia working together with a common view. Just in the March 4th, so 3 days ago, the Congress declared the 4th of March as the National Day for Obesity, to reflect around obesity. That's the World Obesity Day also, but it was declared, and this is important, this is the first time that the Congress is talking about obesity and the importance of having it in the top of the, not only of the public health agenda, but of the policy agenda as something that is needs urgent intervention in a very structural way. And commemorating this day, we have like the main buildings around the country painted in blue, which is and millions of views and commentaries in the social media. And this is more or less the actors that are participating: the Senate of the Republic, the Ministry of Health, World Obesity Federation, the National Academy of Medicine, many national institutes of health, many professional societies, and many academic institutions, together with international organisms and civil society. So very strong, very difficult to oppose this very this group with a common view, and only with people very associated with the food industry against these positions. Yesterday also was voted the new law for the healthy nutrition, in which the state will be responsible of the food that is distributed in schools and in the health system to children in hospitals. Also, is a law that will improve support and will assure support in different regions of the country where there is a lot of undernutrition, which is also a problem, but also will make responsible to the Ministry of Health of designing recommendations for healthy nutrition and promoting the dietary guidelines, and also assuring that children are protected from consumption of unhealthy beverages in the first years of life in a very intensive way. So this is something that also can be a good effort. Then other thing that we did 2 years ago is a position with 10 recommendations, and it was endorsed by more than 1,000 health professionals and was published in our public health journal, and also created a lot of support for different interventions that I am not going to mention in this presentation, but the paper is online. It's called Volviéndonos Mejores. And it was right after the epidemic, and is a pledge to become better in health services, in training, in avoiding bias and obesity stigma with patients in primary healthcare services, improving research, avoiding conflict of interests, and other recommendations. So the World Health Organization is now developing a national, an international, a world acceleration plan to stop obesity. And Mexico is one of the pioneers countries that will start in this initiative. So we are developing a national obesity policy to implement within this international acceleration plan. And these are our objectives for this policy. One is to protect and strengthen the approved policies and maximize their positive impact on the population. So we are very proud of our 10% soda tax, but as I was mentioning, Colombia has now a 25% soda tax, and they consume less soda than us. And Saudi Arabia has a tax of 50% of the cost, and India has a tax of 27%. So we think our soda tax of 10% is now is insufficient. We need to do more than that, and we need to improve all our already implemented policies. For example, we need to protect more to the children of marketing now in social media and in the internet, etc. Then the second objective is to promote and ensure and protect breastfeeding. We are monitoring all the time the code of marketing of of formula feeding. And Mexico is not complying, the corporations are not complying with this code of marketing since 4 years ago. So we really need to adopt this code as a law in Mexico and to protect the population from this marketing from the companies. Also, another objective is to increase consumption of natural water and avoid and reduce consumption of industrialized beverages. As I was mentioning, this is about 70% of the caloric consumption of added sugars in our diet in the country level. So just this objective will be good enough to achieve good results in obesity prevention for the year 2030, so in 6 years. Also, avoid consumption of ultra-processed food products, improve the response of health services at the primary level of care for prevention, diagnosis, and control, and policies to promote and encourage food sovereignty, which is this new national law. It's not a solution, but this law will allow for other actions that will help a lot to improve the diet of the population. So this is basically what we are doing right now. And with this, I am concluding this presentation. It's a small view of our efforts, but I need to say that we are optimistic that we will be able to have the obesity prevalence below 41% in 2030. And that will be equivalent to say that we have a reduction against the predicted level in 2030. So we could be one of the first countries to document a reduction in obesity in the world. However, we don't have that warrant. We need to do a lot of work in the next following 6 years to achieve this objective. So thank you very much for the opportunity to share with you these results.
Thank you, Dr. Barquera. Outstanding accomplishments. Thank you so much. We will have a session, questions and answer session after this block. So we need to hear from Dr. Nayeli Garibay Nieto now. Thank you.
Can you see my presentation?
Yes.
Okay, thank you so much. Good morning, everyone. It is my pleasure to be here to have the opportunity to talk to you. Thank you for the invitation. I am a pediatrician and pediatric endocrinologist. I work in the Hospital General de Mexico in Mexico City. I am a specialist in childhood obesity, and I have a master's and PhD in medical sciences. My research line has been for the past 15 years, risk factors, associated comorbidities, intervention and prevention strategies, and translational research in the field of childhood obesity. If we conceptualize obesity as a complex, chronic, and multifactorial relapsing disease, it will be necessary to intentionally search for associated comorbidities, which may present throughout the entire life cycle. The prevalence of obesity in Mexico over the last 4 decades has increased significantly compared to the global trend and ranks into the top 3 of countries with the highest projected growth in the Americas after US and Brazil. Annual increase and the impact on GDP are estimated to be very high for Mexico. Given the trends reported over the years in our National Health and Nutrition Survey, the expectations of achieving the World Health Organization goal for 2030 of no growth in the problem are barely 4%. For this reason, it is crucial to detect the presence of comorbidities associated with overweight and obesity early on, intending to intervene early to modify the natural process of the disease and prevent these children and adolescents from reaching early adulthood with advanced chronic disease. My clinical setting is at the General Hospital of Mexico. This is the largest general hospital in Latin America, which serves the most vulnerable population without social security, mostly from Mexico City and the surrounding area, and low socioeconomic status, and predominantly urban. So we receive an average of 500 new patients with obesity and their families annually, and intentional screening for major associated comorbidities is performed in a systematic way. As you can see in this slide, our patients have really a high prevalence of cardiometabolic comorbidities, such as insulin resistance, metabolic dysfunction-associated fatty liver disease, dyslipidemia, and metabolic syndrome. Obesity poses an additional challenge for children and adolescents during psychological changes, leading to stigma, discrimination, emotional and social complications, as well as anxiety and severe depression. Concerning glucose tolerance disorders, we must start with the premise that the current diagnostic cutoff points have been tested in the adult population and extrapolated to children, which remains very inconvenient. The prevalences of prediabetes vary depending on the method we use, as you can see, indicating a variability in our patient that goes from 8 to 50%, with higher sensitivity when hemoglobin A1C is considered as a screening test. A meta-analysis published in 2022 outlined that the global prevalence of childhood prediabetes is estimated to be 9%, which is lower compared to our prevalence. Moreover, associated risk factors were described as well in this meta-analysis, and they found that older age, higher BMI, and family history of diabetes were important risk factors. Interestingly, in our population, as you can see, we did not find significant differences in prevalences between the group of school children versus adolescents, nor between the degrees of obesity. Another meta-analysis demonstrated that the highest prevalence of prediabetes is observed in Africa and the Americas. And of course, 10% has been described for these Americas countries. Moreover, in a smaller sample of our patients undergoing an oral glucose tolerance test, prediabetes prevalence was around 10%, and no patients were diagnosed with diabetes. So employing hemoglobin A1C as a screening test, we noted that type 2 diabetes prevalence in our population averages 3%, which is higher than compared to the reported data from other countries. A recent issue report for the OECD countries states that Mexico reports one of the highest prevalences of type 2 diabetes in adults. So we think that the complications in this population will be concerning. On the other hand, we know that metabolic liver dysfunction has rapidly become the most common form of chronic liver disease in children and adolescents. Most studies indicate that Mexican Americans with obesity have the highest prevalence of liver metabolic dysfunction and severely affected by the disease due in part to the expression of the genetically inherited indigenous gene PNPLA3. So the overall prevalence of liver dysfunction has been described in 38% of children with obesity, with a high prevalence in Hispanic and Latino group. As we can observe here in our population of children with obesity, the prevalence of metabolic liver dysfunction is around 50% when using ultrasound as a diagnostic method. This is higher than reported for the pediatric obesity patient group, and as you can see, the severity levels of steatosis are distributed and similar in both groups across different obesity grades. In a subgroup, we assess the presence of metabolic liver dysfunction and metabolic liver dysfunction plus fibrosis. So as you can see, metabolic liver dysfunction was present in 60% of our patients, but look at this, how these patients that had metabolic liver dysfunction plus fibrosis was up to 20%. So of course, it is not yet clear whether these structural damages in the liver tissue can show complete reversibility after intervention strategies. Regarding the presence of hypertension and prehypertension, we observe an upward trend as the degree of obesity increases, and as expected, there was significantly higher proportion of both systolic and diastolic hypertension, particularly in the group of adolescents with severe obesity. In relation to some surrogate markers of cardiovascular damage, we conducted a comparative cross-sectional study to compare the degree of carotid intima media thickness in children with obesity compared to their normal weight peers, normal weight adults, and adults with obesity, just to evaluate if abnormalities were similar in both groups. As you can see on the left, there was a statistically significant difference between the mean intima media thickness when we compare children and adults. We found as well a difference between children and adults with obesity, but the size effect was lower. So when we did an age and obesity model base adjusted by Tanner stage to analyze the estimated means for the intima media thickness, denoting a degree of change that was similar, as you can see here, in children with obesity, they display the same levels of carotid intima media abnormalities as adults with obesity, and the structural damage to the carotid artery in children with obesity denotes adaptations, probably that they are likely to result of genetic, epigenetics, and environmental conditions, causing surrogate cardiovascular abnormalities that are comparable to those observed in adult populations with obesity. An interesting proposal published by the University of Alberta has been the staging of the severity of obesity based on this classification found in different domains that were evaluated. Studies in adults have shown that staging obesity using EOS in adults is a good predictor for adverse outcomes, such as mortality and complications related to some pathologies. In another study by our group evaluating complications associated with COVID-19 in adults, we observed that EOS was a better predictor of adverse outcomes than BMI. In our clinic, we have standardized instruments to objectively assess each one of these domains. As expected, we observed that practically no patients were in EOS 0 in the metabolic domain, and almost 20% of them are in the domain of greater severity, which may include damage to target organs that could eventually be partially reversible. On the other hand, the least affected domain is the functional, which may represent an advantage if the patient can participate in a physical activity program. Only 15% of our patients show optimal mental health, reinforcing the need for psychological and sometimes psychiatric intervention as a cornerstone of treatment. Most of our patients were classified, as you can see, in stages 2 and 3, and the domains mostly affected were the metabolic and the social domain. Surprisingly, alterations in different domains were not associated with the degree of obesity. For us, it has been very concerning to recognize that the vast majority of our population shows complex social determinants, which critically complicates intervention and adherence to treatment. Probably this is the domain in which we have the least capacity for intervention. These patients definitely require a comprehensive treatment focused on their individual needs. Of the most outstanding recommendations recently issued by the American Academy of Pediatrics, it contemplates a comprehensive work with the child and the family at very early stages of the disease based on cognitive behavioral strategies that promote the acquisition of healthy lifestyles, covering a minimum period of intensive face-to-face intervention of 26 hours in individual, family, and group formats. This is the dynamic that we apply in our clinic. However, the limitations and barriers faced by these families make adherence to treatment very, very difficult. In the next few slides, I want to show you the effectiveness of short and medium-term treatments with improvements, as you can see here, in anthropometric parameters. I am showing you here some values in eutrophic and normal weight children. And this is the values for kids in the pre-treatment phase and the post-treatment phase. And as you can see, we have very statistically significant improvements in all these anthropometric variables, as well as in some metabolic and biochemical variables, such as lipids and hepatic function. When we analyze as well the insulin sensitivity indexes and insulin resistance indexes, we observe as well a huge improvement in this metabolic. So in this slide, I decided just to show you with the variables in a dichotomic manner how most of the biochemical variables can improve after 6 months of intervention. But I would like just to have your attention on intima media thickness and stiffness measured by FibroScan in these patients. These comorbidities were not improved in this period. So we don't know if we really need a longer time of intervention or if these comorbidities will not have a relapse. In conclusion, I would like to emphasize the relevance of the international search for comorbidities in children, as well as the need for standardized diagnostic methods and cutoff points for this population. Interventions should ideally be aimed at resolving or slowing down the progression of the comorbidities that may arise. Thank you very much.
Thank you very much for a wonderful presentation, Dr. Nayeli Garibay Nieto. Now we will have very short time for questions, and Dr. Carlos Crespo is moderating this challenging part. Sorry, we're behind. Thank you, Dr. Crespo.
All right. No, thank you. This has been an excellent set of presentations going from the macro level to interventions. So, and we're already running behind. So I'll just have one general questions about how let me because I had it here. You know, how do we convince, and this is one of the comments, the political side to be able to intervene in some of these interventions, especially at the school level? And short answer, because we're already running behind. So let's go with Dr. Barquera.
Oh, thank you, Dr. Crespo. Well, one thing we have seen is that in the year 2010, we approved guidelines for the schools with some recommendations. And we have been monitoring this over the next 10 years, and schools were not complying. Once they realized that there was no responsibilities, there was no consequences of not following the guidelines, many did not comply. So about 3 months ago, we approved a new law, new changes to the law of on education. And now they have to do some actions, and if not, the government can force it and can put can require and have consequences. So I think this is one of the things we need to have, like an infrastructure, a regulatory framework for this. And the other cases, we have the DIF, that is our system for school breakfast, and this is organized by municipalities in the country. So similar to United States, very it's not centralized. And this allows in Mexico a lot of corruption. Municipalities can get engaged in transactions with food industry, with Coca-Cola or with PepsiCo, and that affects the overall result of these resources. And this has been also modified in the law that we just approved. So I think from up down, there is a lot of opportunity improving the regulatory framework. And I obviously understand that also from grassroots, there are a lot of things that can be done, like with support from civil society, societies of parents, etc. So that's at least one part of the perspective.
All right, thank you. Quickly, Dr. Garibay Nieto, what was the most difficult part of the intervention?
Well, as I mentioned, I think that the social milieu is the most difficult. We try very hard to try to educate people about taking good decisions. I know that the government has their own responsibility, but I think that the setting where we can act and we can do some strategies with people is just to educate people and try to get them and try to help them to optimize the resources they have. But I think that this complicated dynamic where they are immersed is quite difficult.
Thank you. Next. Should probably move to the next part of that program. Thank you very much. Great work.
Thank you all. Thank you so much. And now we have Dr. Vanessa Odo, who will start the next block of presentations. Thank you.
Okay, thank you so much. My name is Vanessa Otto, and I am an assistant professor at the University of Illinois, Chicago, in the Department of Kinesiology and Nutrition. My training is in nutrition epidemiology, but my work really broadly focuses on two areas. The first is on the social determinants of obesity and also evaluating obesity prevention policies like sugary beverage taxes or school meals or the SNAP program in the US. But today I'm going to talk about my line of work, which focuses on the association between employment and childhood obesity. So as we've heard throughout the morning today, obesity is highly prevalent. Just last week, new data were released by the NCD risk group in The Lancet, detailing that more than 1 billion people are now living with obesity. And over the last 30 years, obesity prevalence has quadrupled among children and adolescents ages 5 to 19 years old. We know from this data also that more children with obesity are now living in low and middle income countries. And in the US, obesity prevalence is disproportionately experienced. So Hispanic children are 2 times more likely to have obesity than non-Hispanic white children, which was detailed earlier by Dean Crespo, but you can see in the figure on the bottom right screen. So as mentioned, I largely study different social determinants or drivers of obesity among children. And one of my main lines of focus over the last few years has been to look at parental employment as a potential driver among obesity risk. This figure here details sort of the conceptual framework around some of the papers that I'm going to present in the subsequent slides. But at a high level, we know that parental employment certainly affects household economic resources. It affects parental stress, particularly in the US. It affects healthcare access. It also impacts parents' time to prepare healthy foods and to supervise meals. And certainly it affects food insecurity. And these intermediate factors are thought to be associated with diet quality and physical activity, which of course, in turn, as we've heard, an abundance of evidence this morning, impact childhood obesity risk. So today I'm going to talk about 3 related studies that looked at parental employment and obesity, both in low and middle income countries and then in the US context. So in low and middle income countries, I'm going to focus on maternal employment. And because of the ongoing nutrition transition and the rapidly changing food environment in these contexts, we would hypothesize that maternal employment increases economic resources, and this in turn increases the consumption of ultra-processed foods within the household, and in turn increases weight among children. In the US context, I'm going to focus on unemployment and precarious or low quality employment, which I will detail in later slides. But here we're looking at a decrease in economic resources or low wages, which would be associated with an increase in ultra-processed food consumption and potentially an increase in childhood obesity. So this first study, as I mentioned, took place in 45 low and middle income countries. We leveraged data from the demographic and health surveys. And the hypothesis here was that, while employment affords many benefits, potentially there are unintended consequences of more women participating in the labor force. At the same time, the food environment in these contexts is rapidly changing. And so we use the demographic health surveys first to categorize mothers in the samples as formally employed, informally employed, or not employed, not only just based on their employment status, but also their occupation, their earnings type, whether it was cash or in kind or in cash plus in kind, as well as the seasonality of their employment. And so for those not familiar, the demographic and health surveys are cross-sectional surveys conducted every few years in low and middle income countries. They ask a battery of questions related to socioeconomic status, household characteristics. They collect data on measured heights and weights among children, as well as some questions around diet and health. And so for this analysis, we were able to include data from 45 countries between 2010 and 2015. You can see the countries represented in this analysis in the figure at the bottom of the screen. Mexico no longer participates in the DHS, but we did have a number of countries represented from Latin and South America, as well as countries from Sub-Saharan Africa and Asia. And so in this sample, we had about 270,000 children ages 5 to 19 years. And used linear regression and meta-analysis to answer this research question, and did find that formalized maternal employment was associated with a modest increase in BMI Z-score. But I think importantly, we also found that formalized maternal employment was associated with a 30% higher odds of children ages 5 to 19 consuming sweets or foods that were high in saturated fat. And so I think, this speaks to some of the work that we've heard this morning about, the need for policies and interventions to potentially change the food environment. But I also think really speaks to the need for policies to support women's participation in the labor force in these contexts, given, the competing demands of work with childcare in a very obesogenic food or environment. So then I was interested in thinking about this question a little bit more in the US context. And I first did so thinking about unemployment during the 2008 recession. And I focused on this period of time in California for several reasons. The first is that during the 2008 recession, unemployment rates in California were extremely high. You can see here on the right-hand side of your screen, this figure before the recession and currently in California, unemployment rates are around 4%, as represented by that red line. But during the Great Recession, we saw unemployment rates that were, 3 to 4 times that, depending on the year, with unemployment rates peaking around 14% in 2010. California is also home to a very large percentage of Hispanics. And as we heard from Dr. Crespo earlier, the large majority of Hispanics in the US, but in particular in California, are Mexican American. So about 53% of school-age children in California are Hispanic, and a large majority of those, about 84%, are Mexican American. And we also know in this 2008 recession, but certainly in the pandemic-related recessions as well, that Hispanic individuals were 40% more likely than whites to experience unemployment due to occupational segregation and things like that. So this first paper that was looking at unemployment in California utilized data from the California Public School physical fitness testing data. In California, they collect measured heights and weights among kids, the same kids in 5th, 7th, and 9th grade. So we have longitudinal data on every California, every child attending public school in California between 2008 and 2012, and then used unemployment data from the US Bureau of Labor Statistics. In this paper, we had about 1.7 million children, and as mentioned in the prior slide, about 1 million of those children identified as Hispanic. We use the CDC cutoffs for overweight and obesity, which is a BMI of greater than or equal to the 85th percentile, and linear probability models with individual fixed effects to compare each child to themselves over time. So kind of getting closer to causal estimates than we could with just regular linear regression models. You can see at the bottom here that Latino children statewide in California have the highest prevalence of overweight and obesity, far higher than white or Asian children in California. And we did find that for every 1 percentage point increase in unemployment, overweight risk among Hispanic children in California increased by 1.4 percentage points. And so really the public health impact of this is pretty huge. This data was the first to really look at the impact of the recession on children, and did suggest that Hispanic children of average weight could expect a 14% increase in their BMI Z-score in association with every 1 percentage point increase in unemployment. And as I mentioned in this prior slide, we saw really huge increases in unemployment in California. So not 1% increase, but rather 4 percentage points on average. So a second follow-up study looked at the same kind of question, whether unemployment during the Great Recession impacted large for gestational age births. We've, of course, also heard today that birth outcomes are a really important period of intervention potentially. We know obesity tracks throughout the life course. And so here we were looking at the impact of unemployment on large for gestational age births in California. Again, we had birth certificate data from California over a period of 5 years, and had about 1.7 million singleton births during that time. And again, did find a significant association between increases in unemployment rates and large for gestational age prevalence among Hispanic children in California. And so again, really speaking to the public health impact here, large for gestational age prevalence increased by about 5% for every 1 standard deviation increase in unemployment. So finally, this last study here, I was interested in not only employment status, but employment quality. And so the prior studies, focused on whether someone was employed or unemployed. But here I was interested in this concept of precarious employment in the US. And precarious employment does not have one single definition, but it tends to be work that's insecure and uncertain. So not only does someone have a high risk of job loss, but also a low probability of finding a comparable job. They potentially have limited economic benefits. The job likely doesn't provide a living wage, or health insurance or any other kinds of benefits. And it's also jobs that have limited entitlements by labor laws or regulatory protections. So in the US context, we see that we see this often with like the gig economy, Uber drivers, Lyft drivers, those kinds of jobs. And again, I was interested in this for a few reasons. One, we hypothesized that the worsening of employment quality in the US would be highest among, racial and ethnic minorities, but also that this worsening of employment quality could affect weight-related health. And so we tested this question using a nationally representative survey, the National Longitudinal Survey of Youth, and created a precarious employment score, a continuous score, where we, based on the 11 items available in this particular survey, which you can see on the left-hand side of your screen here. Of course, the score included wages, but it also included things like the number of hours worked, shift work, the number of years they were employed at that particular job, as well as union membership and promotion and training opportunities. And did find that employment quality has worsened in the US over this, roughly 30-year period of observation that you can see here on the right-hand side of the screen, and that the highest prevalence of precarious employment is experienced by Hispanic women. And again, a majority of Hispanic women in the US are Mexican. So so then we were interested in whether, precarious employment, maternal precarious employment affected childhood obesity risk. And here we had about 10,000 observations from, 4,500 children in this nationally representative survey. And we looked at the first incidence of childhood overweight obesity, and did find that every 1 unit increase in precarious employment, maternal precarious employment, was associated with a 10% increase in overweight and obesity incidence among children in this sample. We didn't find statistically significant differences between white children of white mothers versus Hispanic or non-Hispanic Black mothers, but we do see, a relatively similar magnitude of effect among these two groups. So to briefly conclude here, this series of papers, I think, does demonstrate that employment status and quality is consistently associated with BMI and overweight risk among children. And I think this really speaks to an earlier point made that we do need to really think about interventions and policies that focus on some of these distal drivers of obesity among Hispanic children. It's not likely that we're going to move the needle on obesity with just one intervention or one policy. Certainly, we need a suite of approaches, but I do think focusing on some of these more distal drivers is going to be very important. And so in the US, I do think, in particular, policies really need to focus on improving the social safety nets during periods of unemployment, and think about improving job quality in order to improve public health among Hispanic children. And so with that, I will stop sharing.
Thank you very much, Dr. Vanessa Odo. We're very proud of you. Thank you for your presentation. Now we have Dr. Mario Daniel Cava Flores, researcher at the University Autónoma de Nuevo León. Dr. Cava, please share your slides.
Hello, good afternoon. Can everyone see my slides correctly?
Yes.
Perfect. I'm going to begin now. Well, good afternoon, everyone. I am Dr. Daniel Cava Flores. Now it's my turn to present you my conference, Human Milk as Immune Health Programming in Newborns, the Role of Maternal Status, Health, and Diet. First, a little information about me. I hold a postdoctoral position at the Universidad Autónoma de Nuevo León. I am currently studying how maternal obesity can modify the expression of cytokines, hormones, and ceramides in maternal breast milk, and how this may impact infant growth and development. First, a little of history. Let's talk about the origins of milk. Milk, the story for answering this, we have to talk about the history of Earth. Now, Earth has around 4.6 billion years of age. And around 4.2 billion years ago, life in Earth appeared. And around 225 million years ago, mammals appeared, which means that in this period of time, milk also appeared. Now, let's consider that during all this time, life in Earth has been evolving. So this means that milk is not just a food. Milk is a gift from nature. But why do we say that it's a gift? Well, it's very easy. It's because milk breastfeeding has a lot of benefits that are not only restricted to the infant, as mother has also a lot of benefits from breastfeeding. There are a lot of benefits. We're not going to be able to cover them all, but I want us to focus on this one. Breastfeeding has protective features for the infant against being overweight and obese later in life, and also protects the infant for metabolic risk, such as a metabolic syndrome or type 1 and type 2 diabetes. For the mother, some of the effects include reduced risk of breast and ovarian cancer, reduced risk of high blood pressure, and of type 2 diabetes. But how are these benefits achieved? Well, in part, this is explained by the human milk composition. Milk has a nutritive part made of water, carbohydrates, lipids, proteins, vitamins, and minerals. But milk has also a non-nutritive, but a very bioactive part. Let's focus on this one. Milk has microbiota, and milk has a lot of components of the immune system, including antibodies, alive cells such as stem cells, eosinophils, basophils, neutrophils, T and B cells, and natural killer cells. This composition of human milk can be modified in different scenarios, such as prematurity, the developmental stage of the infant, namely colostrum or mature milk, but also during infant infections. However, other scenarios, such as maternal overweight and obesity, has been described to change the composition of human milk. Now that we are talking about overweight and obesity, let's talk a bit about some hard numbers. Currently, 1 in every 4 inhabitants is affected by overweight and obesity. And in Mexico, we can know the numbers thanks to the Encuesta Nacional de Salud y Nutrición. Here, we know, thanks to this survey, that the population of 0 to 24 months of age, 5.7% are already overweight and obese. And we can also see that as age increases, this problem also increases, reaching adults of 20 years of age and more to a 75% of the total population affected by overweight and obesity. Now, we have discussed that breastfeeding can be a protective factor for being overweight or obese later in life. However, we have also said that overweight and obesity can change the composition of human milk. And in Mexico, and in the United States, and in other parts in the world, the same trend can be seen. More potential mothers are reaching a reproductive age with excessive weight. And the sector of 30 to 39 years of age, 74% of women are overweight and obese. But how can this impact the programming of the health of the infant? Well, for answering that, we have to slightly introduce, because it has been previously discussed during the symposium, the importance of the first 1,000 days of life. This number is encompassed by the first 9 months of pregnancy and the following 2 years of life, in which the infant is going to feed on human milk. Now, what happens during pre-pregnancy, but especially during pregnancy years, maternal habits such as diet is going to program the infant health and susceptibility or a correct immune and metabolic health. Let's put an example. If during pre-pregnancy and pregnancy time, mother has a diet high in fat and high in sugars, there is going to be a promotion of non-communicable diseases on the infant. And now, if the mother decides not to breastfeed, or if she decides to breastfeed, but she continues having a diet high in fat and high in sugars, there is going to be a defective microbial colonization. And what is the importance of this microbial colonization? Well, in this period of time, microbiota is the most important immune stimulation for the infant. And what other risks can be seen? Well, there is going to be a defective immune response in the infant, and this can put him in increased risk of metabolic trait. Now, what happens if mother decides to breastfeed, and if she also decides to change her dietary habits? Well, all these non-communicable diseases that were promoted during fetal programming can be mitigated or even eliminated. Now, in an ideal scenario where pre-pregnancy and especially pregnancy period, mother has a correct intake of fiber, carbohydrates, and protein, well, it's a very different scenario. The infant is going to have a correct immune maturation, a correct organ development, and a healthy microbial gut colonization, additionally to the known protective effect against later in life overweight, obesity, and diabetes. Okay, how does breastfeeding provide the immunological programming in the newborn? Well, let's remember that milk is very complex, but milk has a immune profile such as antibodies, maternal live leukocytes, also microbiota, and small proteins such as cytokines. All of these are dependent on infant period of development. However, this balance can be modified also during, well, yeah, maternal diet, also body composition such as overweight and obesity. However, age, maternal age, or even if mother has sedentary habits or not, all this can have an impact on the composition of human milk. The exact impact is still under study, but we now know that this actually changes the composition of human milk. Now that we are talking about cytokines, why are cytokines important? Well, cytokines are small proteins that have a lot of roles, but for the infant, these are especially important because they aid in the correct immune development of the infant through the maturation and activation of infant immune cells. And this activation is going to allow the infant to have, as well as together with the cytokines found in human milk, these together are going to protect the infant against infections. And more importantly, cytokines have anti-inflammatory effects. So this is going to protect the infant during an immune response. Now, let's take this into consideration. A newborn has a complete but immature immune system, and cytokines are able to interact and to provide the way for correct immune maturation. And in this scenario of breast milk, milk is an excellent source of cytokines. So this is the importance of breast milk. But what about bacteria? Well, when infant is feeding on human milk, he will find immune cells and also bacteria. Life of both are alive, and they are going to interact with infant saliva. They are going to pass the stomach and reach the gastrointestinal tract. Here, they are going to be able to pass cells to systemic circulation, and they are going to be able to reach organs such as lymph nodes, spleen, and thymus. And here, they are going to be established for the rest of the life of the infant. And this will add features such as enhanced tolerance, enhanced priming, and immune surveillance. This is called maternal microchimerism. What happens with bacteria? Well, bacteria also reach the intestine alive, and here they are going to be able to provide a healthy, good microbiome. As has been previously discussed, this has a lot of effects on the infant, and this can allow the infant to have a correct digestion and a correct absorption of nutrients, but also a correct immune stimulation, a correct immune, and allowing a correct immune response. This can also help in the maturation of the gastrointestinal tract through enhanced integrity of the gut lining and also allowing a development of a strong mucosal immune system that is going to have different roles, including not allowing that pathogen bacteria establish in the gut, but also allowing that commensal bacteria thrive on the intestine. Well, and how is this bacteria selected? Very easy, through maternal dietary habits. If during this period, mother has a correct diet, such as high in fiber, high in carbs, and high in proteins, she is going to have a very diverse and balanced microbiota. And this, when the infant feeds on this correct microbiota balance, infant is going to have a protective effect against inflammation and infection. However, in other scenario, in which maternal dietary habits are focused on high-fat diet, microbiota is not going to be as balanced and as diverse. This is known as dysbiosis, and this is related to infant for the infant with allergies, leaky gut, increased immune activation, and an increase in pro-inflammatory cytokine release. So, how do energy? This is in the case of energy-dense diets, but what is the impact on human milk profile and what is the impact on human milk microbiome? It is still under study. And what is the impact of diet and supplementation on the immune profile of milk? Well, omega-3, omegas, and blackcurrant seed oil are known to have anti-inflammatory effects. And when mother is supplemented with blackcurrant seed oil, there has been some studies saying that some cytokines, such as interferon, pro-inflammatory cytokine interferon gamma increases, and anti-inflammatory cytokine interleukin-4 decreases. However, many of others pro and anti-inflammatory cytokines remain largely unaffected. In a similar scenario, when mother is supplemented with omegas, some fatty acids such as DHA and EPA are increased, but other pro and anti-inflammatory cytokines remain also largely unaffected. What has been seen as a potent intervention has been when mother is encouraged to eat more fruit and vegetables, as this has demonstrated that the pro-inflammatory profile of milk sharply decreases. And thanks to preclinical models, we know that maternal energy-dense diets increases interleukin-6 and the other pro-inflammatory TNF-alpha, and this is related to neuroinflammation in newborns. Now, we still are studying what is the effect of single nutrient supplementation on the composition of the immune and also on the bacterial populations, and also if this reaches the infant and if this can has an effect on infant. And well, as we saw on other presentations, recent presentations, we are now addicted to sugar. We like to eat sugar, but we still don't know what is the exact effect of diets high in sugar in the composition of milk. And the most important question, how does this affect the infant health? Now, what is the influence of maternal obesity on the immune profile? Well, there is evidence that increased maternal BMI has decreased neuroprotective factors in milk, as it has been shown to have an increase on omega-6 to omega-3 ratio and a sharp decrease in fatty acids, including and in the antioxidant lutein. Also, we and others have reported that the immune pro-inflammatory profile of milk also is increased in milk, on the milk. But the big question remains, what are the effects of breastfed child? Is this bad? Is this good? Does the infant respond? For answering that, we need more studies, specifically longitudinal studies, large longitudinal studies. So what are the takeaway messages? Breastfeeding is a form of early life immunization achieved through immune factors and microbiota from breast milk. The first 1,000 years represent a critical window of opportunity for immune health programming. Maternal weight, age, and diet can influence the bioactive composition of breast milk, and the immune profile and microbiota in human milk are related with preventing or favoring childhood obesity and metabolic impairment. What are areas of opportunity? The studies have assessed the effect of maternal diet, including those high in sugar, on the immune milk composition, the contribution of energy-dense diets on human milk immune profile and newborn microbiome is largely unexplored. The relationship of single nutrients and their presence in human milk is still underexplored, and experimental design should aim for a longitudinal scope. For your attention, thank you very much.
Thank you, Dr. Cava Flores, for your outstanding presentation. You will be part of the questions and answers after Dr. Olga Garcia Obregón and Dr. Zambrano Gonzalez. Thank you. So, Dr. Olga, from the University of Querétaro, Universidad.
Thank you. Thank you, Dr. Elvira. And I would like to say thank you also to the organizing committee for inviting me to talk a little bit about what we've been doing regarding food environments and the relationship to childhood obesity. First, a little bit about myself. I am a food chemist and I have a master's and a PhD in nutrition from UC Davis. I am a full-time professor and senior scientist at the Universidad Autónoma de Querétaro. I've been studying micronutrients for basically most of my professional life, and lately we've been looking into some research regarding and related to food security and food environment, and that's what we're going to be talking today. First, there are several definitions about food environment, but for the sake of this presentation, we are going to use this definition. Food environment will be defined as all the available food options a person is exposed to. And we'll be talking a little bit about type of food venues. We're also going to be talking about density and proximity to food venues. Density refers to the amount of food venues that surround a person in a certain buffer or certain radio. And proximity refers to the distance from where we are, where we live, where we work, or where we study to the first food venue that we encounter or what is around us. And also, food environment also takes into consideration food access within the food venues. What are the kinds of foods that are available next to us or close to us? Now, the study about food environment and obesity and its relationship has been going on for a while. However, results have been not quite consistent. And this is basically because there are several differences of ethnic groups that have been studied, also different age groups, and there are also differences between studying rural versus urban areas, and actually studies define these areas differently. So this is why there have been inconsistency. And also there are different countries, and we should, as you listen to my presentation and you see our results, we have to think that food environment is a very local thing. It's something that is very particular for certain areas. And as I mentioned before, this has been not done in a lot of countries, but mostly developed countries and in urban areas. Some of the key findings of these studies that have been already published in these developed countries have shown that the proximity to supermarkets has been associated with lower risk of obesity. That is, if you live close to a supermarket, your risk is lower. And this is basically because you have more access to fruit and vegetables and healthier foods. On the other hand, what has been observed is that if you live close to convenience stores, you have a higher risk of obesity. And this is precisely the opposite as what happens with supermarkets. If you live close to convenience stores, you have less access to healthy foods and, of course, fruits and vegetables. So what we wanted to do in our research group was study what the food environment was in a very local, rural community in Mexico, in Querétaro, where I live. And studies have been done in Mexico regarding food environments around schools, but we wanted to see what happened in a very close and controlled community. And we studied the relationship between food environment and body fat percent in school-aged children in the rural community of Santa Cruz in Querétaro. In order to do that, we did a cross-sectional study, and we included over 200 children from 6 to 10 years old, and the community is located in the municipality of El Marqués in Querétaro. That's about an hour away from Querétaro City. We measured anthropometry and body composition of all the children. Now, how did we measure food environment? You can measure food environment several ways, but what we did was use a geolocation of all the convenience stores, or what we call in Mexico the tienditas or tienda de abarrotes. And I want to emphasize that we geolocated all the stores in the community using GPS. And we also used GPS to geolocate the households participants where they lived, and all this information was collected. We also measured food in store availability, and for that, using a measuring tape, very simple, you go into the stores and you measure the shelf length in meters or centimeters of how many processed foods are available, or non or minimally processed foods are available. And this was done by a two-person team. Then how did you analyze this data? You create a geographic information system database constructed, geocoding all the tienditas and the participants' households using a program called ArcMap 10. This way, you know exactly where they are in a map, as I'm showing you right here. On the left, you're going to see the density of the tienditas, and on the right, the proximity to the tienditas. each green spot is a food venue, and the participants are I think they're the blue ones. And we also quantified the shelf length of each type of food. Now, some of the results of this study, on the left in the graph, you're going to see the body fat percent. And we divided the exposure to tienditas in quartiles. The first one is when a child is exposed to none or 5 tienditas. And the fourth level is when it's exposed between 26 and 31. And yes, the number is right, that in this community, one child could be exposed to 31 convenience stores around its household. And as you can see, the children that were exposed to between 26 and 31 tienditas had higher body fat compared to the others. And in those tienditas, the majority of the food that was available was processed foods in 70%. Regarding the relationship with obesity, we saw that density was associated with higher body fat. That is, the more tienditas that were close to the household of where these children lived was associated to obesity. And in terms of proximity, the closer they lived to a tiendita was also associated with having higher body fat. Now, we wanted to replicate this study in an urban setting. So we did a study not only looking at food environment, but we also wanted to look at obesity also in school-aged children. And we incorporated food insecurity in the equation. The results that I'm going to present to you are preliminary. We're still analyzing the data. So what did we do? We evaluated the relationship between food insecurity, food environment, and obesity in school-aged children from 2 local low-income urban areas in Querétaro, Mexico. This was also a cross-sectional study. We included over 100 children of Santa Rosa, Jauregui, and Satélite, and we also measured anthropometry and body composition in all the children. We also geolocated all food venues in the 2 areas and the participants' households in Satélite and Santa Rosa. In this case, we measured the density of food venues in a 1.5 kilometers radius. We increased the radius because in urban settings, distances are longer. And we're currently measuring the density and the proximity of the food venues to where the children live. And the preliminary results show that almost half of the children had higher body fat percent from these 2 communities. We found over 2,000 venues, food venues, and were geolocated. This was an enormous task. We didn't expect to find this many food venues in urban settings. We also geolocated the participants' households. And just to give you a very brief expectations of what we found that 24% of the food venues that we observed were restaurants. We included all kinds of restaurants. And very close by, almost 23% were tienditas or tienda de abarrotes. This was followed by foods of animal origin. That means carnicerías, pollerías, cremerías in about 11%. And we found 8% of the puestos ambulantes or mobile food stalls. These were the top four. And we found more tienditas in Satélite compared to Santa Rosa. The rest were very, very, very similar. And this is an example of what we're currently doing. We call it heat maps, as in the microbiome studies. And each point is a food venue. And the preliminary results show that the children that had higher body fat lived closer to food venues that sold mainly processed food, particularly tienditas. And they lived in households with severe food insecurity compared to children with normal weight. These are results that we're currently processing, and we hope to have them published soon. So in conclusion, food environment is associated with obesity in school-age children in a rural area in Querétaro, and may be associated in low-income settings in urban areas. Changing food environment is a challenging task, and I want to emphasize this because it doesn't depend only on, it depends on many things, but it depends on globalization, it depends on urbanization, and it also depends on other factors such as economics and politics. The tiendita is a very, very, very important economic model in Mexico, and changing that is not going to be easy. And it has been proven that this economic model is also very important for women, because most of the women are the ones that are in charge of the tienditas. So it's a way of living of a very, very, very huge part of the Mexican population. However, if we study the food environments and we understand the food environments, we're going to be able to promote environments that support healthy eating and thus help prevent obesity. So if you see, after we've heard all these talks, we know that there are genetic factors. We know that there, Dr. Crespo said that not all these genetic factors. There's a lot of environmental factors that are included, and food environment is one very important risk factor for childhood obesity, and is one of the hardest that it's going to be. Is going to be one of the hardest to change. I want to acknowledge the participation of all my team and my students, and of course the mothers and the children that participated in the study. And gracias.
Thank you very much, Dr. Garcia Obregón, for your outstanding presentation, and we will answer questions from the audience after the next speaker. So now we have Doctora Elena Zambrano González, is the last presenter of the last block of presentations, and we're closing with a seal of gold with her presentation. So thank you, Dr. Zambrano. ¿No le escuchamos?
Okay.
Gracias, ahí está.
Okay, thank you very much. First, thank you for the invitation to participate in this very important webinar. I'm Elena Zambrano González. I live in Mexico City, and I work as a researcher in the Instituto Nacional de Ciencias, Médicas y Nutrición, Salvador, Zubirán, and as a professor in Facultad de Química de la Universidad Nacional Autónoma de México. Today, I'm going to talk about interventions to prevent adverse developmental programming due to maternal obesity, and I'm going to present a kind of explanation to understand mechanisms using a preclinical model. So as several speakers have talked before me, the phenotype is determined by genetic factors, but also by the environment with a more effect at early stage of development. So the phenotype is the interaction between gene and environment. This is called developmental programming or the developmental origins of health and disease. And as other speakers have said, in a more colloquial world, the first 1,000 days of life, and I'm not going to explain that because it's already explained. So clinical and experimental animal studies have shown that suboptimal environment as maternal obesity or as maternal nutrition may predispose offspring to lifelong health metabolic problems, including obesity. Our group worked with the Wistar rat as experimental model, and we use the undernutrition model, and we know that almost all the negative effects that are in the maternal obesity, we also see them in the undernourished mother. But I'm going to talk today about the maternal obesity. So we have two groups: the control group, that the mothers are fed with controlled diet, and the high caloric mothers that are fed with, we call them maternal obesity. And something really, really important is after weaning, all the pups are fed with controlled diet. So any negative effect is because the maternal diet, or any benefit because the maternal intervention. But the offspring are fed only with controlled diet. We studied this in many ways, like fetal, neonatal, lactation, puberty, adult, and until they are very old. And we study brain, liver, fat, metabolism, sexual reproduction, everything. So I'm going to present, for the interventions that I'm going to say, only one of the impacts to show like examples of what we do. But normally we take advantage of the animals and we explore everything for each model. So here are the interventions. The interventions are very, very, very important because, as other speakers said previously, it's better to prevent than to have then the diagnosis and then to act. So with this maternal obesity, we have several interventions: probiotic, exercise, the hydroepiandrosterone, resveratrol, and the dietary intervention. And then we explore what happened in the offspring, in the effects, because the mother was obese or because the mother was intervened. The first one is maternal probiotic intervention. Well, something good for this model is we take the bacteria from the aguamiel, that is a typical sweet rum from Mexico, and we already patented this probiotic. So we gave this probiotic 1 month before pregnancy and lactation to the obese mother, and we then explore what happened with the offspring. The first result, in very general way, is that there are different microbiota in the intestine of the mothers. In the obese mother, is different than the lean mother. For example, the Firmicutes bacteroidetes ratio is much higher in the obese mother in comparison with the control. But if we supplemented the mother with the probiotic, this ratio is similar than the control. We always have the intervention also in the control group to see that there is no any negative effect. Because, for example, we have one intervention with metformin, and for that one, there was not good response for the control group, but that's another story. So here we have the parameters of the mothers at the end of lactation, and even if they weigh exactly the same or similar, we can see that the obese mothers have more fat and more triglycerides. But if they were supplementing with the probiotic, the results are very similar than the controls. And when we explore the offspring, here I'm going to present first the male. We can see when they are young adult, young, because when they are old is another story. The body weight is similar, but they have much more fat, leptin, and triglycerides. But this effect, negative effect, we don't see it if the mother was supplemented with the probiotic. And I'm showing here the female data because we found a very important sex dimorphism results. For example, at this age, there is no negative effects in the female's offspring, neither improvement, but at this particular age, because when they get old, we can see negative effects too. So the conclusion of this part of the results are that probiotic intervention in obese mothers changes maternal microbiota and improves maternal and offspring metabolism. Now the next intervention, maternal docosahexaenoic acid supplementation, or DHA. Once again, we have 4 groups, the control and the obese mothers, and half of them supplemented with DHA. The offspring were fed with controlled diet, so any impact is because of maternal diet. And the first thing that I want to show here is that this is the histology of a control mother of the mammary gland and the obese mother. And as we can see here, the parenchymal tissue is less developed than the control group and more fat. And at the end of lactation, we can see that the milk composition is very different, is very, very heavy, lower production, more fat, and lower long-chain polyunsaturated fatty acids, which are very, very important for the brain development. The obese mothers in general have less concentration of DHA and eicosapentaenoic acid and more corticosterone levels, which are negative for the offspring development, programming development. And this goes through the placenta and through the milk during pregnancy and during lactation, which has a negative impact in the offspring brain development because it has less DHA in the brain of the fetal and the neonate. We tested in different ways of the behavior. I'm just going to present one of them, that is anxiety. The anxiety is tested by the Elevera Plus maze, which has 2 open arms and 2 closed arms. When the rat is scared, spend more time in the closed arms in comparison with the open arms. And we can see that the offspring from obese mothers have higher concentrations of corticosterone, and males and females spend less time in the open arms, which means that they have more anxiety. But if the mother is supplemented with DHA, we can see a recuperation of this value. We also tested other things like memory, associated memory and spatial memory and learning. And of course, there is a negative effect of the offspring from obese mothers that can be prevented with the DHA intervention. So the conclusion of this part of the study is that maternal obesity generates in the offspring more anxiety, less learning and memory. But if the mother is supplemented with DHA, these negative effects can be prevented. The next intervention is maternal resveratrol supplementation. Resveratrol has many qualities. One of them is a good antioxidant. And we gave the mother, we have once again 4 groups in which we supplemented the mothers with resveratrol in the controls and in the obese mothers. And we once again study the offspring. And here I'm presenting the maternal parameters before breeding when the mothers were supplemented with resveratrol. We can see that even if the body weight was higher, the real difference is that the obese mother has more fat, adiposity index, fat cell size, insulin-resistant index, triglycerides, leptin. But if the mother was supplemented with resveratrol, some of these parameters return to the control value. When we measure the oxidative stress in terms of different parameters, we can see that the obese mother has an increased oxidative stress. And of course, with the resveratrol supplementation, this goes down as similar results than the control group. And what happened with the offspring? Well, many good effects. I'm just going to present very few. Here we can see that the amount of fat, leptin, and triglycerides are much higher in the offspring from obese mothers, but are returned to the control group if the mother was supplemented with resveratrol. And I like very much this picture. These rats are males. They are cousins, the same grandmother. They are old. This is an old age. Because when they are young, the weight is very similar in between the control and the obese offspring. but we already have more fat since they are young. But at this age, it's so clear with the picture. Here, the same grandmother, the mothers were sisters. The only difference was the diet or the supplementation. And as we can see here, the offspring from obese mother is much heavier than the control and other many problems. But the mother from obese mothers, the offspring from obese mothers supplemented with resveratrol looks very similar than the control. So the conclusion of this part of the study is that maternal resveratrol intervention in obese mothers reduce maternal oxidative stress and maternal metabolism and prevents some of the offspring negative outcomes due to maternal obesity. The next intervention, maternal dietary intervention, in which something very important is not that the mother is on diet. The mother that was fed with high-fat diet, we switched the diet to control group, to control diet, just to a healthy diet 1 month before pregnancy and lactation. And what we can see is the males and the females offspring when they are young, we can see some metabolic parameters as insulin resistant index, glucose increase in the males offspring in comparison with the control. But if the mother has this switch of diet 1 month before, it can help to improve the metabolism of the offspring. Here we have some histologies of the liver in terms of fat and triglycerides in the liver. And the first very important thing is there is a sex dimorphism in which the offspring from male offspring from mothers, obese mothers, have more fat and triglycerides in comparison with the females. But if the mother had a dietary intervention 1 month before, this is completely prevented in also males and females. And here the picture that I like very much too, when the animals are old, these are males too, how it looks, the dietary intervention offspring, the dietary intervention in the mother, in comparison with the control and in comparison with the offspring from obese mothers. And once again, these are cousins, the same grandmother. One important result of this part of the study is that it was not necessary that the mother return to the normal weight, the obese mother, to have benefits to the offspring. So well, it maybe the goal looks very difficult to reach, but with a small change in your life, you can change the whole life of the next generation. Well, the very last intervention, and this is my favorite, definitely, is the maternal exercise intervention. We have a gym in our animal room, and here, once again, we have 4 groups, the control and the obese mothers, and the ones that exercise 1 month before pregnancy and pregnancy. During lactation, they did not exercise because they didn't like it, and this is a voluntary exercise. So we explored the offspring, and in very general explanation for males, for example, when they are young, there are no difference in body weight, but it's a clear difference in terms of fat, adiposity index, leptin, and triglycerides. But if the mother exercise, those data are very similar than control. So it was very important that the mother did a very small intervention because it was a voluntary exercise. It was not an exhaustive exercise. And in terms of the liver, we can see here the male and the female livers in the histologies and the fat. And we can see a recuperation of the accumulation of the fat in the liver in the offspring, male and female, if the mother exercise. And the picture, maternal exercise intervention in obese mothers before and during pregnancy prevents some of the offspring negative outcomes due to maternal obesity. These are once again cousins, the same grandmother, and one very important, and they are old, and these are male. One very important thing here is that there is also a positive programming because the offspring from control mothers that exercise were the best in terms of metabolism, in learning, in memory, in sexual reproduction, sexual development, reproduction, in everything. So there is also positive programming. And I'm not presenting about the fathers, but there is also impact with the father lifestyle. This is like a kind of summary of 3 pictures in which we can see very clear that the offspring of obese mothers, these are males, have more fat, but with these 3 interventions, as we can see in the pictures, we can prevent the accumulation of fat. So programming with the dietary intervention, all the interventions, we can prevent negative offspring programming, and not only to have a longer life, but a better quality of life. And I'm not presenting the offspring intervention, but also with the offspring intervention, we can see different mechanisms, but an improvement in life. When does the health problems start? And definitely, what do we want to inherit to our kids and the kids of our kids? And pregnancy and lactation are windows of opportunities. I want to say thank you to all the group that we work in with this field and all the grants that we receive. Thank you very much.
Thank you so much, Dr. Zambrano, for your kind presentation. And now we are moving to the part of questions and answers. Please write your questions in the chat before we finally move to the final conclusions that we have here with Dr. Marta Kaufer. So please write your questions or open your microphone and we can answer your questions. There is a poll that is going to show to appear. Please let us know what is your institution. That's important to share with you more information. There is a question, I believe, 1 second in the chat. 1 second here. Okay, let's see. Some have been already answered by the speakers. Thank you for that. Dr. Mario Daniel Cava, what is the mechanism by the microorganisms from the mother's gut microbiota pass to the mammary gland and reach the milk? So that's a question for Dr. Mario Daniel Cava. Are you there to answer that question? Okay, let's see.
I can say
Dr.
something.
Zambrano, yes, please, go ahead, please, Dr. Zambrano.
What I can say is that during the parturition and also during the lactation, the microbiota of the mother goes to the offspring, and that helps to the establishment of the microbiota of the offspring. That is very important at this critical period of life. Okay. So the programming effects are not only around the metabolism of the mother, but also the microbiota of the mother.
Thank you. There is one more question here for you, Dr. Zambrano. Was the intervention dose used in the experimental trials physiological?
Well,
physiological. Mm-hmm.
I think that for humans it's very difficult to change the lifestyle, but definitely the best intervention are to change the lifestyle. So I would say that the exercise and the change to a good good food or good good food. But all the interventions, because sometimes if the mother does not have time, there are supplementations that can improve some of the mother metabolisms and pregnancy.
Okay. Thank you very much. I think we will stop here and we let Dr. Marta Kaufer-Horwitz do the integration and closing of this session. Thank you so much.
Thank you very much, Dr. De Mejia. I will try to summarize the most remarkable findings or elements that our speakers shared with us today. So we started with Dr. Crespo, who talked about how the United States and Mexico have the highest prevalence of obesity among the OECD countries, and how if you are of Mexican origin and live in the United States, you have double exposure. He also pointed out how a sedentary lifestyle is a risk factor for obesity, and how watching TV promotes consumption of high-calorie foods in children. So physical activity is a very important component, and inactivity is higher in Mexicans from a younger age. Then we had Dr. Sofia Moran, who talked about the role of gut microbiome in metabolic complications and in the metabolic syndrome in school-age children. This is a very novel topic that raises the need to address dietary strategies to promote a positive microbiome. She also talked about the challenges of recommending probiotics in this population. We moved on to Dr. Claudia Tovar's presentation on holistic strategies for child obesity prevention. And interestingly, she suggested that more than just taking into account the first 1,000 days for obesity prevention should encompass 8,000 days. That is the whole childhood age, or particularly up to 18 or 19 years of age. She addressed the importance of taking into account environmental factors as well as parenting styles in developing strategies to prevent obesity in children. Then Dr. Sharon Donovan focused on the first 1,000 days and pointed out a new area of personalized nutrition. And I thought it was very interesting that she pointed out that human milk is the first example of personalized nutrition. I think that's a very important and interesting information. She also pointed out that personalized nutrition in the first 1,000 days is underexplored. We moved on to Dr. Margarita Teran's presentation on childhood obesity prevention family-based programs. She presented a wonderful family prevention program, culturally appropriate and susceptible to be reproduced in many different settings, not only in Hispanic populations in the United States, but I think her program can be also adapted to many settings in Mexico and maybe in other Spanish-speaking countries. After that, we had Dr. Simón Barquera, president of the World Obesity Federation, our keynote speaker. Dr. Barquera presented interesting data on how Mexico has been an example for the world in proposing effective public health strategies to address the problem of obesity. Some of Mexico's strategies have been adopted by different countries along the globe with very good results. He also pointed out the barriers that should be addressed if we want to decrease obesity prevalence in the near future, not only in Mexico, but all over the world. After that, Dr. Nayeli Garibay presented her topic, which was primary comorbidities associated to obesity in the pediatric population. And it was very interesting to note how she showed that comorbidities that were very seldom seen in children in the past are now very prevalent. She also presented a novel comprehensive program at her institution geared at families of children and adolescents with obesity. And she showed how these family programs can be very, very effective. We moved to Dr. Vanessa Otto that presented a very, very interesting and seldomly explored subject on employment and obesity. It's often overlooked and how unemployment affects children with overweight or obesity, and more so in Mexican American children that are typically underprivileged. Then Dr. Cava Flores presented a very interesting topic, which is human milk as immune health programming in newborns, and the role of maternal health status and diet, and how diet is so important for the microbiome composition in the mother and in the newborns and in the milk. He provided elements to promoting breastfeeding We know that the prevalence of breastfeeding in our countries is not optimal, and it has benefits not only for the newborn, but also for the mother and the society as a whole. So also he presented how obesity in the mother affects the milk immune profile. So we should address both problems at the same time: low prevalence of breastfeeding and high prevalence of obesity, and treat those two subjects concomitantly. After that, Dr. Garcia Obregón presented the relationship of food environment with obesity in low-income settings in Querétaro, and she pointed out that food environments are very local, and its effect on health status varies according to the setting. I found her characterization of food environment as a very creative one, as they measured the length of the processed food shelves in the tienditas, and also geolocalized the tienditas close to households, and how this was related to obesity, and how this differed in rural and in urban settings. And finally, our last speaker, Dr. Elena Zambrano, she talked about the interventions to prevent adverse developmental programming due to maternal obesity. She and her group have developed an interesting animal model to explore how obesity affects the offspring in terms of microbiota, anxiety, memory, and she presented remarkable interventions to prevent adverse consequences, including antioxidant supplementation, healthy diet, exercise, and how this affects the offspring of obese mothers. And finally, well, these were our speakers, our wonderful speakers. I would like to thank the University of Illinois system and IMA's initiative, particularly Dr. Elvira de Mejia, for this outstanding morning. I really enjoyed it. Also, we thank our very expert panelists for their wonderful presentations. And ultimately, we are grateful to our very active attendees for being here and for their very interesting and provocative questions. So I don't know, Elvira, if you would like to have a final comment.
Thank you so much, Dr. Marta Kaufer-Horwitz. Thank you for working with us since the very beginning, since the generation of the ideas, with Dr. Claudia and Dr. Carlos as well from the University of Illinois, Chicago. So thank you to all the speakers for their outstanding presentations and for sharing new knowledge with the audience. Thank you to the hundreds of attendees this morning. And I hope this webinar will spark new collaborations and a sustainable understanding and partnership between the universities in Illinois and Mexico. With gratitude to all of you, we close this webinar. Thank you very much.